It's something like this. The Internet of Things is a network of devices, of things connected to the Internet that enables these objects to collect and exchange devices with no human interaction. It's quite boring, right? Really, Internet of Things is actually pretty simple. It means taking all the things together in the world and connecting them to the Internet. Yeah. So generally, IoTs is a combination of information technology and operation technology. Information technology is something as your hardware and your software, like your web browsers and internet, etc. While your operation technologies are like the sensors and the your touchscreen mobiles. So connecting both of them together brings on IoTs. Some of the statistics related to proving the pricing of the market for Internet of Things. By 2019, the global IoT market will generate a revenue of more than $1.7 trillion. As of 2018, nearly half of all the IoT devices were connected to the wireless personal area networks. And by 2025, there will be more than 648 Internet of Things devices worldwide. So that's quite a projection there. So IoTs is all around you. You can see this is a mobile phone which tells you how many sensors are there in your phone. You can see that there are almost 38 sensors in that particular mobile phone. Any wearable tech that you have is an IoT. IoT is in your AC, IoT is in your fridge, it's in your vehicles. When you have a GPS attached to a car, it's all about IoT. And of course, healthcare. IoT is all around you. So what about sensors in agriculture? So let me give you a brief overview about sensors in agriculture. So there are wired sensors. Wired sensors are mainly used when you have to cover a very short distance and your devices, your main device and your sensors are not very far. This particularly is not feasible in a very long, very wide area, but there is something called the wireless sensors. So wireless sensors are more apt for using in a bigger area. Wireless sensors are of two types, the terrestrial wireless sensor network, which is called the TWSN, and the wireless underground sensor network. Mainly, the terrestrial wireless sensor networks are used for calculating the environmental and the plant parameters, and the underground sensors are used for calculating the soil-related parameters. There is something called an actuators as well. What is the difference between a sensor and an actuator is, sensors are mainly used for only sensing and monitoring, while the actuators are also used for controlling the actions. So something about how the terrestrial wireless sensor network works. So you have your plain field in which you have your wireless sensor nodes installed throughout your field. These wireless sensors communicate with each other through various types of communication links. These wireless sensor nodes are not connected to the internet, but it requires an internet facility to transmit this information from the sensors to your device. So there is something called a gateway node. This gateway node has an IP address, it has a SIM installed in it, or a capability to transfer the information collected from all these sensors to the internet. Then this internet, through this internet, it can be used by a remote user on a desktop or a mobile phone, or it can be stored in a database or a server, where you can do the data visualization and also apply some analytical tools. We also have the other kind of sensor network, that is the underground sensor network. So in this scenario, the wireless sensor nodes are not above the field, it is underground, where they communicate under the ground through the communication links. In this scenario, there are two gateway nodes available. So you have your gateway node with it, which is under the ground, which transmits information to a surface link which is above the ground. And then in the same scenario, that surface link transfers the information to the internet, and so on and so forth. So the difference between the terrestrial and underground sensor network, mainly placed over ground and buried under the ground. The terrestrial sensor networks have a very small antenna which is not barely visible, but for using the underground sensor network, you need to have a larger antenna. Energy consumption and cost is lower in case of terrestrial sensors, while it is higher in case of the underground sensors. When you speak about the network architecture of this sensor network, there is various kind of classification. The first one is on the basis of the node movement. So there are three types: stationary, mobile, and hybrid. Stationary, as in when the sensors are fixed at one place, like the soil moisture sensors installed in the field. Mobile sensors are like if you have installed some sensors in the tractor and the tractor is moving around in the field on the basis of the movement assigned to it, or a drone. Hybrid sensors are when it's a combination of both the stationary as well as the mobile sensor. Type of nodes, when it is homogeneous or heterogeneous. Homogeneous is when all the sensors and the gateway have the same kind of technology behind it. But when it is heterogeneous is generally what happens, because the sensors have a different type of backend technology attached to it, and as well as the gateway has a different kind of backend technology. Based on the system hierarchy, we have a single tier as well as a multi-tier hierarchy. Single tier hierarchy is something which you already saw when it is in the terrestrial field, when it is over the ground, while in case of multi-tier, it is used mainly to hop signals from one field to another. When you want to transmit information through a number of fields and cover a large area, and then you want to set up only one gateway, so how to do that? So you have your sensor nodes installed in all the fields. These sensor nodes have the farthest of the fields have the 3-tier gateway attached to it. Then you have the 2-tier gateway, and there is a 1-tier gateway. Information is transferred amongst the field with a sensor gateway communication. Then the gateway communication happens. The 3rd-tier gateway transfers information to the 2nd-tier gateway, and the 2nd-tier gateway in turn transfers information to the 1st-tier gateway. Then the 1st-tier gateway transfers the information to the remote sync node and is transferred to the internet. This is how sensors work in a very large number of fields. So there are some of the associated factors when you have to assemble the components for installing sensors. Like first one is what are you trying to sense? Is there a sensor available for it? So you have a sensor, which is a sensing unit, and the actuators. Whether you want to do the computational there and then with the sensors, or you just want to sense the information and monitor the information. Then you have to keep in mind the processor and the storage, because this adds up to the cost of the equipment, and also the transmission unit. Which kind of communication link are you using, how expensive it is, what is the distance you are trying to cover through this transmission unit. Also, what kind of power facilities are you using? Are they solar powered, or they have a battery backup when there is no solar power. How is it? But ultimately, everything drills down to cost. What is the cost of the sensor? What is it going to cost me if I'm installing these many sensors in this much area of field? So there are some of the examples which I have collated for you, where you can see the soil-related sensors. So there are various parameters that you can calculate. That is soil moisture sensor, rain, waterfall, water flow, water level, soil temperature, conductivity, salinity. There are a combination of sensors available in the market, and upon your requirement, you can select which sensor to go for and make your decision. There are many environmental related sensors which calculate for you, sense for you, humidity, ambient temperature, atmospheric pressure, wind speed, rainfall, and solar radiation. There are some plant related parameters as well, like the moisture, temperature, hydrogen, wetness, CO2, photosynthesis. The sensors are not limited to only these parameters. There might be more sensors available, but it is up to the user, first of all, to decide what they want to sense and what is available in the market or not. Suppose you want to go, if a person decides, I want to sense NPK value, but there are no sensors available in the market, or maybe one under test, which is sensing the nitrogen. So I spoke to you about the various communication technologies in which the sensor uses to communicate amongst each other and also with the gateway. So these are some of the examples. And you can see most important is the transmission range, which is using. So these are, the Zigbee is only 10 to 20 meter. Wi-Fi is a little bit higher. The most frequently used nowadays is LoRa, that is long range, which can transmit information to more than 10 kilometers of distance. So actually, there was a study conducted to find a reference architecture for agriculture. What is a reference architecture? Reference architecture is kind of a template of architecture which you can directly just pick from the shelf, make some minor tweaks here and there, and use for your application in the field. So for coming up with a reference architecture for agriculture, there was we actually conducted a study where we studied reference architectures from various technology partners, as well as open source initiatives and research groups. So there were we identified some of the common elements, trends, and transferable components from each of the our study subjects, and then we propose a reference architecture for agriculture, which can be used as a pan-Cgiar information architecture. So from the technology leaders, we studied Intel. So in Intel, you can see that there is a communication and connectivity layer. There is a control layer. There is a security layer. They gave more emphasis on the security layer because securing of the data collected by these sensors is very important. You can also see that there is an interchangeability between the APIs which can be used, because Intel is much more into the hardware. They have designed a very easy infrastructure for us to use. You can take management layer from the Intel reference architecture and use it anywhere. So mainly the structure is divided into three parts: things, network, and cloud. The things are the sensors, some of which are connected to the internet and some of which are not. The network is the network connectivity, and through which the information goes on the cloud. The second one was from Microsoft. It is also divided into three parts. One is things, insights, and action. So in the things, you can see there are various IoT devices and IoT edge devices, from where the information is collected and it goes to the cloud gateway or the IoT hub. From there, the IoT hub passes on the information. The most interesting part of this architecture is the warm path store and the cloud path store. So cold path store signifies that when you want to save some information only for some short duration of time and use it in very near future. But warm path store means that you want to store that information for a longer duration of time and you use it in a long term. So this is about Microsoft. Since Microsoft deals with big clients, they have also decided to have a high availability and disaster recovery layer along with the deployment and the security layer. The reference architecture from Google, it gives you, the census collects information and it goes to something called an Azure ML TensorFlow. It also has a Linux OS instead of any other operating system which are more commonly available in the market. Then you have the Cloud IoT Core. Mainly, most of these blocks, they have a different name, but they have already been covered in the Intel. They almost have the same information. From IBM, you can see IBM mainly focuses on the user layer. The rest of the part is fairly common throughout the architecture, just the nomenclature is different. They mainly focus on the user layer where they have focused on the user experience. Now, most of the IoT reference architecture don't focus on the user. Some of the open source initiatives. So the first one is Eclipse. So in Eclipse, you can see that they have software stacks for constrained devices, for gateways, and for IoT cloud platforms. There is many similarities between all these three stacks. You can see communication, data management, and messaging is used for transferring of information and connectivity as well. Then you have the operating system or the real-time operating system. In this, also the operating system used is Linux, even though there is an option to use a real-time operating system. Then you have the remote management, and here you have the routing facility. This is another example from an open source initiative, which is the MainFlux Labs. MainFlux mainly engages in this scenario where the connected device are on one side and the application on the other side. It is basically in the middle. If you see the diagram below, this is the connected devices, and here you have the applications. And the same kind of reference architecture is followed here as well, where you have the operating system, the security, and the data management is there, and also application enablement. From the research groups, actually this was a study conducted in 2017 where a reference architecture for agriculture was studied. In this, they studied that there is a perception layer and a control layer. In the perception layer, they are trying to sense only, they are only trying to sense the parameters. But in the control layer, they are also trying to control those features using an actuator. It is called the physical layer. Then there is a communication layer, where they have various types of communication technologies like the Zigbee, NFC, Bluetooth, etc. And via internet, it goes to the service layer, where you have your security and your analytics and other things. So last one is the application layer, where actually the user experience takes place. FarmBeats is again from Microsoft. So mainly the feature that they have different is they use TV white space to transfer this information. TV white space is a radio frequency which is not used by televisions, analog televisions, and they are free to use, but they act in the same manner as the TV frequency takes place. So this is a reference architecture that we have developed based on the study that was conducted. So we have, as the transversal layer, you have one second. The developer layer, and the data integrity and security layer. So during our study, we found out that the ontology layer is one of the important thing that needs to come here. Ontology is a study where all the traits are studied and they come at a single parameter which can be understood by everyone. So our ontology layer, like all the data is connected from different types of sensors in different formats. So ontology layer converts this data into a single format which is understood by everyone. Then you have your device layer, where you have all your sensors, and the communication layer is the connectivity between the different types of sensors and connection from the gateway to the internet. IoT middleware layer is somewhere where all the decision makings and analytics takes place. The service layer, and then you have your application layer where the user experience takes place. It has also given huge importance to users, where the user experience should be as per the users, and you should have the flexibility to decide what kind of parameters you want to see and study, and also the availability of different APIs so that it can be harvested, the data can be harvested into different types of modelings. So this is about the reference architecture. Thank you.
Good afternoon. I don't know if there's supposed to be a moderator or what. Anyway, we will start shortly with the presentations. Okay. Okay.
So we are now following up this with the data for phenotype panel. Since I have presented my part from 1:30 to 2, let me just finish my presentation for the data and phenotype. So after speaking about the communication technologies, so what are the IoTs available at ICRISAT now? So few days back we have installed this arable mark devices here at ICRISAT. Few of you who might have attended the IoT field tour with me for the past 2 days might know about this device. So these devices actually are installed on a pole and at the top. So this is how the top looks like, and all the 4 blue lights blink when it is sensing information. The parameters that it collects are precipitation, evapotranspiration, radiation, Ndvi, chlorophyll index, temperature, relative humidity, and pressure. It also provides you an option to support add-ons, which are the soil moisture probes and the wind speed and direction sensors. So it also calculates only generally the idea is to install these sensors 1 meter above the final plant height. So suppose if your plant height is about 2 meter tall, so you have to install the sensors at 3 meter. Even if you are starting at a stage when it is just after the seedling and after the, it's in a very early stage. So the idea is to install them at a very early stage and to collect data for the complete cycle. How and when the temperature is what, the precipitation is what. So how it helps us, in designing different crop growth and disease modeling systems, where you know that, okay, at this temperature, at this water level or this precipitation, these kind of diseases can happen. So this is what. This IoT device installed here at the ICRISAT campus sends us information on a dashboard for which the access will be given, and only those devices which are installed, you can see the information only for this. The parameters that it collects are weather parameters and plant parameters. The weather parameters, like it will give you the minimum and maximum temperature, and it will also at the same time give you a daily forecast. You can see here at the bottom, it gives you a daily forecast and also an hourly forecast of the rainfall as well as the temperature. This is the plant dashboard. In this dashboard, you can see the irrigation that has happened, and also what will be needed for the next week. Upon the calculation with the rainfall and the precipitation, it has calculated. It also gives you the evapotranspiration and the precipitation with the chlorophyll index and the Ndvi. So all these parameters included are very important source of information and data for a crop phenologist or agronomy perspective. It also gives you an ability to get that information in a form of a graph, and also export that information in any CSV or an Excel format, which can be used again in your modeling, in your modeling systems. So this is how it is done, and the idea behind installing these IoTs is to give you an overview of how IoT works, what kind of data, how the data will be visualized on your system, where you can use this data, and actually it has an API which can also help the scientists to get the information and directly move it to your crop modeling systems. So that's it from me. Thank you very much.
All right. Good afternoon, I'm Berta. I'm working at the Impact Evaluation and Learning Cluster, and I'm working with the community of practice of ontologists, as well as the socioeconomic community of practice. So now you will be wondering why I'm here presenting at the IoT session, and I hope that after my presentation you have a better idea about it. So, it's like this? Which one is it? Right, sorry. So we work with drones, which is similar to IoTs. However, we just collect images from the drones, and some of them have sensors attached to it. So what I want to do is to talk you through the annotation of the data that you'll be collecting before it gets too much and we cannot manage the old data. So we'd like to get to a point in which we can work with the interoperability of all the data that we collect. And you will see that the phenotyping data integrates with all the areas of our research. So you collect at plant and at farm regional scale. And the primary traits of interest, I'm sure you are very familiar with them, as well as additional traits. They are as well for high throughput phenotyping, drone imagery, and sensors. When we collect an image, we have a log of the metadata, and that is the vocabulary that we collect. That will classify the image. And these are various descriptors that include, in the case of the drone, there's the flight, what were the weather conditions of the flight, the height, plus other sensor type. So everything will be specified and characterized. That gets annotated in a database. Here we have a prototype for an interface where you can actually query the data that you are collecting, but the future is to integrate all the data, so it should be everything interlinked. This is just to discuss that here we have the experimental data, which is the date, the name of your experiment. This is obvious in other experiments, like even crop experiments. It doesn't need to be high throughput. But all this data is important when we go to the device. In the drone's case, what's the camera type or what's the sensor type? Because whichever device you are using, the data that you will be annotating will have specific characteristics to that device, plus general characteristics to the overall experiment and the traits you are analyzing. And here is where we are with the control vocabulary. It's not an ontology yet, if you notice. And that's why I'd like to raise awareness, because it is important that many communities of practice and working groups come together before we have too much data and we have different vocabularies and annotations. So if you notice in the notes, you will see the traits. We have canopy height. This one, it's not exclusive to drones. It's not exclusive to crops. It is a very general trait, but if you look at the description, that makes it more specific to either the device or the methodology. Then we have three types, or three definitions, two definitions for chlorophyll, but then three definitions for vegetation index. And vegetation index, as you are well aware in this community, it's a really, really important trait. And that's one of the ones that's giving us more questions. So my point raised, we have the community of practice that works on ontologies. And other than providing expertise, if you don't have it in your center or your areas, it's also for knowledge sharing. So we shared here our control vocabulary, but maybe other centers or communities have a more evolved vocabulary or more comprehensive. We have right now 51 traits cataloged there with different devices. So it would be great if we can raise awareness of annotating your data now, coming to an agreement in which we are all on the same page in terms of words and vocabularies. And just a little bit of a publicity, if you allow me. These are the communities of practice of the ontologies, and the working groups. So there's plant phenotype ontologies, which has crop ontologies and plant stress ontologies that also will tag very nicely with the phenotyping and the drone imaging sensor analysis. Then the other one is agronomy as well, and then socioeconomic survey data that if you look at the impact, for example, if we work with crops, we analyze crops at the farmer level, we analyze crops at the crop management level, at the physiology level, and at the genomic level. So actually what you want is to have a proper ontology that will allow you to link all the fields along the research institute and your areas. Otherwise, there's no way you can measure your impact of your research. And if we go a bit further, we'd like all the crops that we are analyzing to be tagged at some point in geographies or in traits and other aspects. So that's like a little bit of looking further. And just a question that I launched to the audience. If you are interested in an image ontology, and if you want to join, please approach the community of practice directly if you can find it through the conference database. The webpage. Otherwise, we'll just get in touch with you. And you don't need to be a semantic expert. You should be an expert on your field and have an interest in getting your data properly curated and annotated. So, thank you.
Okay. Well, good afternoon. I'm Jan de Bane. I'm the Global Head of Breeding here at ICRISAT. And my presentation is next. And I want to address sensor technologies and their application potentials, especially in the context of the Internet of Things. And then also looking at how we can employ this type of technology to drive data-driven decision-making processes. So I'd like to start off with a quote here from one of the previous CEOs of Apple. And he basically said, if we're going to implement a new technology, let's make sure that we use it ourselves. And so let's practice what we preach, is basically what he said. So this is accompanied with a photo of Steve Jobs in 1980. Since I come from a breeding background, I work now at ICRISAT. Before that, my career has been mostly spent in industry. And so I want to present the Internet of Things in the context of, genetic gain. How can we utilize this data to help us be more effective in our breeding material and in our selection processes? So those that are familiar with the genetic gains equation will probably recognize this right away. And where the you know, these sensors and the Internet of Things can play a big role is probably in the accuracy part. And I'll talk a little bit more about it. So data accuracy is an important component in crop improvement processes to transform it into a data-driven decision-making science. And so first, of course, a lot of this week has already been talked about data systems, and you know, to make data-driven decisions, it is handy if we have a data visualization tool, for example. We need to ensure that we have data integrity, that we have a real-time backup of the data as we collect. To have data access, at least within the institute, there should be a shared database and system training and updates so that everybody is aware of the newest technology, and digital data recording, which is pretty much practiced widely now through tablets and other mobile devices. The quantity of data is also important to really make, to really drive data decision type of making. So multi-location testing is critical, and then also making sure that we're testing in the right target environments, and enough of the target environments as well. And then also collect metadata. The metadata provides context to the primary data and helps us make decisions with greater confidence. The other part also, of course, is quality. We're looking at data accuracy, experimental design, that's where it starts, and then, you know, the type of metrics that we collect, the right statistics, and then, as the previous speaker pointed out, the ontology, making sure that we're on the same, that we're speaking the same language, and then documentation and accountability, so that the people that collect the data, that they can answer for what happens. The metadata, there are several categories under metadata, and again, many of these have been covered. One is target production environments. Provides good background for decision making. I'll expound on that a little bit more in the next slide. We can collect planting and harvesting coordinates. It works very well if we use a GPS type of sensor that records when it was planted, how it was planted, and how it is harvested. And then weather data at the testing sites, for example, which the first speaker already touched on as well. Soil data, which soil profiles and soil moisture content, especially critical when we're doing abiotic stress evaluation. And then fertilizer and sprayer regimes. Again, that can be connected through a GPS sensor that records when it was done, you know, how the equipment ran through the field. It can record all that. And then field or plot history. Often when we encounter anomalies in experiments, if we can go back to the history of the field or the plots, it provides an explanation of what we see. So then going to a more granular level, looking at plant characterization. Important is to start at the basics, so moisture content readings, for example, of the grain that we harvest. And then we can also evaluate organic composition through near-infrared spectrometry, and elemental composition through X-ray fluorescence. And then linking that with molecular data, since we're talking about the Internet of Things, you know, in some of the big seed companies that I worked for, a lot of molecular data is automatically from the sequencer downloaded into a big database. Then the analyst can access that data, link it to the phenotypic data, and provide an explanation for it. The same with marker data. And then hyper or multispectral imaging really provides a type of sensor data that we cannot see with our naked eyes or through regular images. And then some of you have seen the LYSIS scan here that we have at ICRISAT, which can take 3D images and link it with the lysimetry to really provide a lot of data regarding the abiotic stress events, for example. So to optimizing and phenotyping through appropriate use of metadata, the drive is really to shorten the data collection processes, to have sensors in place that can do the data recording for us, basically. And then also increase the accuracy and the quantity of data. When we utilize sensors, again, you can preset them at specific intervals to record data as the day goes on, or as the weeks go on, or months, or years, season. And so that is very valuable. And then also, we need to link that with increased analytical capacity. So once we get all this data, what do we do with it? We need to analyze it correctly, and then that can provide the contextual interpretation for the primary data when we're looking at all this metadata. And it provides us tools to make decisions with greater confidence. So here's an example, courtesy of Dr. Yana Kolova and Sunita Chowdhury, where we're using imaging to evaluate the target production environments. In this case, it's for pearl millet. So they basically use geospatial data and records, government records, to basically look at the area. This is the total pearl millet area in this example that was recorded. And so the darker areas, the resolution isn't too good, but the darker areas have greater number of hectares versus the lighter areas. And then this image looks at total production, so the tons that is produced in each of these areas. And then this representation is the total yield. And again, the darker areas is where the yields are highest. The lighter areas is where the yields are lower. So that provides then metadata to really help us drive decisions in where to test, where we should be focusing our breeding efforts on, etc. And then for increasing, again, going down in resolution here, increasing accuracy of plant characterization through application of sensor technologies. So first, we need to ensure that we select the right type of sensors for the characterization that we want to do. And then after we select the right sensors, we can increase accuracy and also throughput, which is essential when you run, for example, a big breeding program. The time reduction and the throughput will determine the cost of each of the data points. So it is important to really do that. But we cannot sacrifice quality for that. And then also, again, we want to ensure sample accuracy, and that's why identity is preserved, or should be preserved in the samples or in the seed packets that we handle. And then increase analytical capability. Again, with all this data, we need to make sure that we can process it, and then also aptitude, or in other words, how do we interpret all this tremendous amount of data that we work with. This is a little example from one of our breeding programs at ICRISAT, where we use X-ray fluorescence to select high iron and high zinc sorghum lines. And so, again, the sensors provide the data. This system is very robust. We take a number of samples to validate what we're doing, and it also is very strongly correlated to the ICP, or what is called inductively coupled plasma mass spectrometry, which is basically the validation system for the X-ray fluorescence that is being used there. So again, this is high throughput, very robust. It is non-destructive, So the seeds that we analyze this way can still be used for the next generation. And then we can use all this data to start modeling and start developing predictive models for what we can select for. And this was courtesy of Dr. Ashok Kumar. So what do we do then? You know, how do we implement this? In the Internet of Things, how do we make sure that we have buy-in from the people that can benefit from this? And so this is where we need to drive transformation through adoption sensory technology by looking at change management. And so often what we want to do is basically present the urgency of doing science in such a way. And now with a small group of people, you create a coalition that is willing to do the work, the sacrifice, and are excited about this new type of technology. And then you develop a vision and strategy that you can then communicate to the larger group, and really being able to form a vision for the whole organization. Then you empower the action. In other words, you endorse it and you resource it adequately. And then you need to ensure that you get a few quick wins. The quick wins will be used to demonstrate and really leverages to drive change in the larger organization and drive sustained change. And at the end, then, we can embed this type of mindset in the culture at the organization. So, you know, progress is impossible without change, and change makes us grow. And that is what part of this conference is all about, is how can we implement some of these new technologies and drive change. Thank you. So this is now open for discussion and having a conversation around the topic. So if you raise your hand, we can get a microphone out to you. So if you have any questions or comments or suggestions, or this is really an interactive session, meant to be an interactive session and not just presentations.
Thank you for the nice presentations. So I'm Elisabeth Arnaud. I'm leading the Ontology community of practice that Bertha introduced. I was thinking about the fact she said that it's very important to think now about a kind of standardization of how do we call things before you are submerged by the data that are high speed generated by the devices. But I was wondering, when you do multi-trial evaluation, first, do you deploy the same device everywhere to make sure that the data are generated the same way, the same threshold, the same calibration? Is it a mandatory parameter when you do multi-trial assessment with all the devices you are using, remote sensing?
Yeah, so at ICRISAT, we have not fully employed this. So in my previous job, where I came from, it was done within the company. And so there it was a little bit easier to set standards and make sure that people comply with it, because, you know, it is job related. And I think, and this is probably a good discussion point when we talk about standardization, making sure that sensors are validated, that we're all using the same language, and that's where Ontology comes into play as well. I think it is important that we have these, these communities of practice where we can kind of get on the same level, get on the same page. Did you have any?
She's my boss.
Yes, your boss. So I think, yeah. So in a pub, to try to employ this type of technology in public institutions will require a strong drive and desire to really come together and accomplish this. It is almost voluntary, is my experience been in the last year and a half.
And, based on the experience I know from the high throughput phenotyping platforms that are trying to work now as a network in Europe, in US, they are trying to find common ways of developing their databases, because data are stored in very high capacity servers, but if they want to compare for a crop high throughput phenotyping from one platform to another one, then they need to have a common way of storing, describing, analyzing the data. So it's also a concern for high throughput phenotyping network.
Yeah, very, very good point. And I think that to pull that data, there are technological ways to make that more efficient. But definitely, yeah, there has to be some standardization across crops as well. That's where it becomes very valuable.
Yeah, regarding the data format that you are saying, all the data that is collected by the sensors and is upon the dashboard can be downloaded in either a PDF format or an Excel format. The ontology factor that we want is, like, suppose we are talking about Ndvi or the chlorophyll index. So how do we understand these values having effect on the crop, on that particular crop at that particular stage of the life cycle it is? So that kind of understanding actually we want from ontology.
Yeah, thanks, Peter Carberry from ICRISAT and Kanika. I know that you lead the training around the Internet of Things with NABARD, one of India's rural banks. Can you tell us something more about how those, what's the consequence of that training and how those banks might be going to implement the Internet of Things within their business practices?
So actually, we have conducted almost around 6 of the trainings for NABARD officials and other bank officials throughout India, mainly on digital agriculture and Internet of Things. So after those trainings, we have gotten actually quite a lot of support from their sides and queries from their side, and also they have requested our help in building up proposals so that they can submit to their management and implement in the FPOs. Actually, NABARD is a very big promoter of FPOs in India. So they fund those FPOs, and they, there is a lot of support from NABARD as well to implement IoTs in agriculture in India. So actually, we have gotten at least 3 of the requests, I can tell you, from NABARD, where we are moving forward with their request to implement IoTs further.
Hi, to add this point, I'm from NABARD. Actually, I attended one of the IoT program here 2 months back. And last year, we have supported one IoT project of Kisan Raja, IoT in irrigation. They are providing IoT in pump sets. So we have supported one program, and all over India, we are actually supporting IoT projects. And one of the mandate of this year, financial year, in NABARD is promoting IoT and biotechnology, precision farming, etc. Thank you.
Because no one else is putting their hand up, I can ask another question. But I have a background in physiology modelling, and back in the 1970s and 80s, there was efforts to create minimum data sets for modelling and ontologies and common names, and it never worked. What have you learnt from the 30-year history of trying to create this community of practice and getting common understanding of that. I mean, given that this has been tried, as I say, for 30 years, without, I think, much progress in being able to get common approaches across the various groups working around the world. How realistic are you?
Yeah. I think that there are two ontologies that are released already, which is the physiology ontology, the crop ontology. And what I've seen, because I'm from the socio-economic ontology, and I understand what the difficulty is all about, I think they actually started with common ground. And from fine-tuning the terms and the definitions, getting to actual compromises, and they finally, they have enough terms to release an ontology. And I think it works at the same time, the definition with the standards as well. And the more experts from all the areas that are interested in that ontology, the better it goes. Later, when you release it, you find that it's more, there's more buy-in for that.
Can I follow up?
Mm-hmm.
Can I follow up?
Yes, please.
You said you're from the social sciences.
Yes.
So there is, it's not just about starting again and starting from a base, it's about understanding human behaviour. What's going to incentivise people to use common ontologies? There must be lots of research and studies around this, and how do you draw on that understanding of people's behaviour to implement a new program? So it's, you know, your answer there seemed to me the same articulation I heard 25 years ago. You know, what have we learnt about trying to create common views about being able to drive a practice forward from the research?
From research. So I will answer, maybe not your question, but then I'll pass the mic. But so basically, I can speak from my experience, and from the socioeconomic perspective, I think that it is difficult to convince people that by setting up a standard or a definition, they are sometimes at the beginning, it's not their definition in particular, so sometimes it's neither nobody's definition, but a bridge in between. I think the buy-in is in looking at the bigger picture. And the way I look at it is, for example, I don't know how familiar you are with the reporting for the CRPs. We use Mel and Marlowe. When I talk to specific people, and I'm making an analogy here. So when I talk to specific people, nobody likes the system. And I'm sorry to say that really loud in public. But I say, you are having 15 centers with totally different work. We all compromise. Nobody's happy except system office. But the product that you get at the end when the dashboard will be released, it's going to be really, really powerful. And I say there's always room for improvement. And from my impact assessment point of view, I want the geneticists that release a variety with that code. Then it goes to field trials, ontologies, physiology, testing, crop management. I want to go to the farmer and figure out what the farmer is doing with that particular variety. And the only way I have to track it, it's not by variety name, but by the ontology code of that variety. Same with now we are having every time more ways of measuring the same trait. But at the end of the day, it is the same value, the same, not the value in absolute, but the value in meaning, in semantics. And I think if we don't compromise at some point, and if people don't see the value of putting all the data together, which means through a controlled vocabulary, we will not get the impact that the centers deserve and the impact, which we are going for SDG 1 and 2 at least, isn't it? So they should see the way beyond their experiment. I think that's the first step. Then we'll talk about the semantics.
Yeah, I agree. I guess it's a little bit easier again to do this in a company where you say you do this or you're gone. But I think we have to see the value of having a common platform that is really where the power is to have large data sets and being able to access this.
If anybody has any question. So maybe we close this session. I would like to submit something actually. I would like to leave you with this in mind when you're thinking of IoTs for agriculture. Actually, the biggest fight between deciding which kind of sensor or which kind of IoT to implement in your field is between cost and accuracy. So whether you want to go for a costly device which is more accurate, or whether you want to go for a least cost, a little bit lesser cost, and can have a standard deviation of some percentage. So according to what I have come to a conclusion is maybe for a research perspective, you have to go for a much more accurate, and you can go for a costly device. But if you want to reach the farmers, the smallholder farmers of India, you have to go for maybe a cheaper sensor, and they can actually maybe understand the situation and go for a standard deviation in the results that have been achieved. So maybe that, because when I interact with people and they come up with a question that, okay, I want to implement an IoT, what sensor should I use and what it will cost? Will it be accurate? Actually, I don't have an answer, because this study actually has not been done till now, whether which is the best sensor and what kind of standard deviation it will have, or for a research perspective or a farmer. Maybe that can be a takeaway or a food for thought. Thank you very much.
Hello? Oh, sorry. Sorry, everybody. How's everybody doing? It's a big room. If anybody wants to come forward a little bit, feel free. Yeah, there you go. Thank you. Thank you so much. I'm really happy to have this team of speakers coming up next. They have offered to self-organize, so I'm going to let them take it away as they're ready. Thanks, guys.
Hi. Okay, perfect. Okay. These are not my slides. Should I turn next or? Okay, perfect. Hello, everyone. My name is Nicoletta Giulivi, and I'm very grateful for having been invited to speak at this conference. I'm speaking on behalf of my other 3 co-authors, as well as myself. So Aureli Haru, David Gerena, and Srinivas Gautam. I'm from McGill University, and we did a project in partnership with CIMMYT to generate evidence on how we can harness information and communication technologies to provide advisory to farmers, so for extension service. And we piloted our research in Nepal. So the main things that we wanted to look at was to test different ICTs, since they're now growing and expanding in developing countries, and also traditional extension trainees have received a lot of criticism for their high implementation costs and low reach for farmers living in geographically dispersed areas. So with this project, we just wanted to test a radio program as well as voice recorded messages, a smartphone app, and then compare between these technologies as well as comparing them to a traditional extension training. And we wanted to see how this can improve learning and adoption of new agricultural practices and technologies. Since this conference is about trust, it's convenient because we actually also looked at how farmers' trust levels affect the way in which they adopt the information and they trust the different sources through which the information is conveyed. So we gave the same advice across all the tools in the experiment, and that was just a simple advice on when to apply fertilizers on maize crops. So we just told them to apply DAP fertilizer only at planting, and then to split the application of urea at V6 and V10 stages. We selected these tricks in the areas that had internet connectivity, and we worked with farmers who had access to smartphone and a radio in case they will be randomly assigned to receive these treatments. So the blue shaded area is all the coverage that is currently in Nepal. So as you see, it's expanding. And the circles in green are the districts we operated in. We conducted a randomized control trial. This just means that we randomly selected 900 farmers, and we randomly assigned them to receive either one of our treatments, so 150 in each treatment arm, and everyone else was in the control group, so they didn't receive any recommendations from any digital tools. So we used first difference analysis to do the results, and then cross-sectional estimates to check the validity of the results. I'm not going to go into the details, but just for reference. So as I said, we were looking at 3 main things. So one, whether farmers learned from the information provided via those tools. This was tested. We made them take an agronomic test score. So they conducted a test where we asked 6 questions regarding the advice that was provided. And farmers took these before and after receiving the treatments. For adoption, we asked them whether they had followed our recommendation, again, prior to the intervention and post-intervention. And then for trust, we couldn't really conduct an experiment with farmers, so we just used survey data, and we asked them 3 standard questions that measured trust in strangers, just to see trust levels amongst farmers and see how that affects adoption from different sources of information. Okay, so these are the results. So regarding knowledge, we find that both the smartphone and the training, like the smartphone app and the training programs, are the best to help farmers learn about new practices. So in here, here, what this is telling us is that there's farmers who received the information via their smartphone app and the training achieved 6 to 7% higher test scores in the agronomic literacy test compared to farmers who did not receive any information. This is for the adoption of DAP, so our first recommendation. In here, we see that the most effective, actually, if we look at the first two columns, which is basically the main results, we see that none of the tools induced higher adoption of this practice. This is because in Nepal, urea and DAP are substitutes, so farmers tend to use more urea since it's cheaper. However, if you look at the last two columns, we do see that the IVR, which is basically just farmers received a call, and then when they picked up, someone told them about the agricultural advice through a voice-recorded message. This one seemed effective. Maybe this was the case because this practice was very simple to explain, and so farmers could retain it better just from an auditive tool. But this was not the case for our next advice, where we see again the app and the training being the most effective and increasing the likelihood of adopting our urea fertilizer recommendations for the app between 8% and for the training between 12 to 13% probability. This it's also a result of the because these are like more complex practices. We had to explain farmers how to identify if the plants have already reached V6 and V10 stages. And so maybe the fact that the app and the training had a visual feature because they had slides made it easier for farmers to retain the information and then apply it since it was more complex. These two tools had also a very important difference compared to the radio messages and the voice response messages, and is that these tools required a person to go to farmers' communities and share the tools with them. So actually the human interface between the technology and the farmers might have also increased trust in the source of information and therefore led to more adoption. So finally, we looked at farmers who trust the less in the sample. So this is the farmers who are least trusting of strangers and other people in general. And we see that they have a 10% probability, like 8% on average, probability of adopting our recommendations if those come from traditional technologies, such as the radio and the extension training, but they seem more reluctant to follow our recommendations if they receive them via a smartphone app or the voicemail, like the voice recorded messages. And this makes sense because if they're more likely to trust, they're less likely to trust strangers, it's plausible to think that they're also going to be less comfortable with more novel and untraditional technologies. So wrapping up, I have here put the cost effectiveness. So this is how much each of the treatment costed in total. This includes design and implementation, and I've ranked them from cheapest to most expensive. So the best tools overall were the smartphone app and the training. You can see that the ICT tools are cheaper than the extension training. However, in here, for example, you can see that even though the smartphone app appears as the second cheapest, but it's not considering the cost of owning a smartphone since farmers already had a smartphone. It shows the potential for ICT tools to complement extension services, but we're definitely not at the stage where we can substitute them completely because, as I said, the in-person interaction likely played a role in the results. And just a final remark, all of these treatments were delivered by CIMIT, which is a very well-known and established organization in Nepal. It's been there since 1985. And the fact that this provider is so well-known and has a good reputation, it's also has also a likelihood of having inflated our adoption results. And maybe if this experiment was replicated in a context with an unknown provider, perhaps like the adoption rates wouldn't appear as high. But thank you very much. On to the next presentation.
Great, thank you so much for having me as well. My name is Rick Ngandi from Digital Green. And imagine for a moment that you're an agricultural extension worker charged with training farmers on an improved technology or agronomic practice. Farms are difficult to navigate and communities are large and diverse. Over the last 13 years, what we've been involved with at Digital Green is partnering with existing public extension systems, largely of government, as well as civil society and the private sector, who are involved in trying to boost farmer productivity through demonstration plots, farmer field schools, and other types of extension methodologies, and where we've introduced to them the use of videos that are produced by and for farmers to share best practices, because we find that the first questions that farmers, when they watch these videos, is not about the return on investment or the economics of a particular practice, but really who is the person in the video and which village is he or she from, to establish trust to say that this practice that is being featured is something relevant to themselves. Over the last 13 years, we've scaled up this approach to about 2 million farmers across 6 countries in Africa and Asia, and we've been able to improve the cost effectiveness of these extension systems by a factor of 10 times per dollar spent. But the purpose of my talk today is really to share with you how the data that we collect at Digital Green in partnership with our government partners has an opportunity to do a lot more than what we do today. So for instance, when a video is being shown to a group of farmers, we collect a ton of metadata related to what was the attendance at that video screening, the names of the farmers, the location, the time, the practice that they were exposed to. Or at the time at which these videos are produced, we also collect a bunch of other data related to which farmer was featured in the video, what's the language, the crop, the seasonality, and the like. And that data ends up being very interesting for multiple purposes. So one type of purpose is for a monitoring or targeting purpose, which is primarily for our extension partners, like these government ministries of rural development and agriculture in places like here in India as well as in Ethiopia, and where they can look at analytics dashboards like this and be able to see that data that was captured at the time of producing and showing videos in a geographic and time dimension to see what is the most popular practice in a particular time or place, or what's the least popular practice at a particular time or place. Now that same exact data can also be used for a different purpose. This is our videos library, which is used more at a district or a block level, more as a knowledge management tool, so that all of these videos, about 6,000 videos in 30 different languages, are then available for organizations and various types of extension agents to sort and browse through these videos to figure out which videos perhaps they might want to learn and share with each other, and not just the static videos themselves, but tagged with the actual data about how each video was utilized at the community level in terms of how much viewership or adoptions of different practices a video received. Another type of visualization is to place it on a Google map so that we can see how the types of feedback or adoptions, that data that we're collecting, might give us some indication about vectors of pest or disease incidences that might be spreading, which can be used to inform the production of new videos based on some of these types of issues that might be emerging. Another type of use case for data is for creating incentives or ladders of achievement for both farmers as well as the extension agents that are showing these videos and watching these videos. So in a tool that we call Farmer Book, you can actually see a stack rank of these individual farmers and extension agents with respect to how many videos they watched and how many practices did they adopt. And you can zoom into an individual woman who may have watched a series of videos. And this tool is useful from an empowerment point of view so that the farmer herself can be able to see how the practices that she did may have varied with somebody else in her self-help group of women, and perhaps there might be an opportunity for learning and sharing within their community. It can also be very powerful for linking with other types of tools and applications altogether. So we built a tool called Kisan Diary, where this is a tool called Loop, which is an Uber pool for farmers to take their produce to market. And what we're able to do is take the data about what practices farmers are adopting to link that to which markets that produce could be sold, essentially from like a traceability point of view. In addition, you can build another application like Kisan Diary, where farmers are maintaining records about their sales and expenditures so they have a sense about how much they're earning. And this data, again, can be linked to the types of practices farmers are learning, adopting, or connecting with markets. Sort of in summary, where we are as an organization is to say that as an organization, just like many of us all here in this kind of convening, we've all built various suites of agriculture technology solutions. We each collect data about farmers, and they may be various aspects of the value chain that they are pertaining to. In some cases that are about adoption data, in some cases that are about market price realization. But there's a real opportunity for us as a community to go beyond our individual organizations and build a common infrastructure in just the same way that we think about infrastructure like physical roads, human capital, political institutions, finance, and do so with data. Data which we place not into our hands, but that we place back into the farmers' hands so that they have control over the permissions about what data is collected about them and what data they end up sharing with the various services and organizations that they might choose to do so to achieve a higher objective. That's where we see the use of data is really not to be an end goal of itself or something that we as an organization want to take over, but rather something that we can create as a good for the farmers to own and be able to use in an interoperable way across multiple types of applications and services. And that's why we have created a new tool called FarmStack, which is meant to be a very thin layer of data standards and APIs to enable organizations like us, as well as others, to be able to share and learn with one another and to pass back the data and the ownership and control back to the farmers themselves so that they have greater agency and choice to take their one small step toward improving their lives and those around them. Thank you very much.
Yes, good afternoon, everybody. Peter Carberry from ICRISAT. I want to thank the organisers for giving me a chance to join this session with two colleagues here, because it's something that I've been banging on about a lot when we talk around digital agriculture and digital decision support systems. And so it's great to be here. I had the opportunity on the first day to welcome people to ICRISAT, and I referred to something about that then, and I want to go into a bit more detail. I've found a couple of slides to put up here, but I'm not really talking about my work at ICRISAT. This is from when I was with CSIRO in Australia, working with Australian farmers. And this figure up here, this first figure, represents the profit and loss from a real farm in Australia. And I use this figure a lot. This farm is in the Mallee in Victoria in Australia, 15,000 hectares of cropping, a big farm. This farmer has access to the best technology you can have. It has access to modern equipment, to advisory services, and access to me. And when I was with CSIRO, to provide advice. And we gave this farmer advice around climate forecasting, around what the likelihood of different investments might be, like his fertiliser, etc. And you can see over this period here, this from 1990 to 2010, that he made profits in many years, but you can see the big losses that he made, he and his family, over this period when it was there was a persistent drought in Australia. So the point of this figure is here is a whole farm profit and loss from a real farmer, John Ferrier, and his son David and wife Robin, and they had access to the best technology. They used digital support. They used digital agriculture, used seasonal climate forecasting, they used the APSIM model, and yet they still made incredible losses. And this is the reality that we talk about when we talk about projecting or forecasting the future and providing decision support. And in a venue like this and in a forum like this, when we want to talk about providing recommendations using the latest scientific knowledge and tools to deliver, we have to be realistic about that. Often when you provide the best advice available, you can still be wrong in that particular year. And I want to see more of this articulation come through, this probability of success and probability of failure come through when we talk about providing recommendations, particularly to small farmers. Now, John Ferrier and his family, they can absorb those $1 million losses in consecutive or every second year because they have equity in their farm. And they can go to the bank and say, okay, I lost $1 million this year, and so my equity will go down, and they can operate the next year. But if you're a small farmer in the Sahel in West Africa, and you have if you get advice to invest in a particular way, and there's a drought and failure, the consequences on you and your family are much greater. So this is the reality of climate variability, of agriculture in dryland areas, and those people that are building applications, decision support systems, tools, you have to be conscious of that. You can give the best information in the most sincere, ethical way, but you're going to be wrong a certain percentage of time, and what the consequence of that might be. And how do you deal with that going forward? Now, having said all that, that John Ferrier used this tool that we developed in Australia called Yield Profit. It was developed by a group of farmers to service farmers, and it combined information about seasonal climate forecasting, soil water, investment decisions such as fertiliser, and so any farmer in Australia could adapt this tool to their own farming system. And you know, as most people do in these fora, I put up a success story. These are the farmers I'm talking about here. In a very dry year, a decile 2 year, they made investment decisions based on that information that turned out to be successful. You know, I could put up an equivalent outcome where they made investment decisions based on all the information had, and they ended up with a very bad decision. The idea, though, that is if you use this information and make those investment decisions over a 10-year period, you're going to be right more often than you're going to be wrong. And that's probabilistic nature of these farming systems and the advice we give. Now, this is a detailed slide. It should be animated, but I'm just trying to make the point here that often when we talk about agriculture, we talk about that bottom grey box or blue box. It's the production system, it's the crops, the livestock, the pastures. But agriculture consists of another box that sits above that, and that's the farmer, the management system, the cognitive processes that people go through. And it's the interplay between what's the biophysical system and the farming system is where decisions are made. And this whole field of decision support, what we call apps today, information systems, has a 40-year history. And the reality is of building these hard systems models of the biophysical system captured in our decision support systems and provided advice to farmers has failed. There's a problem of implementation. And that's been documented many times over the last 30 years. It's hard to find, for the millions of dollars of investment, for the hundreds of tools and programs that have been developed and provided to farmers, it's very hard to find a successful, sustainable system that's still in place today. So this problem of implementation, we have to understand, well, why hasn't this worked better? Is it because we haven't had the computer speed, we haven't had cloud computing? Is it because we didn't have smartphones back when this started in the 1950s, 60s, 70s and 80s? Is it the hardware problem or is it another problem? And I would put to you that, again, another complex slide pulled from some work that we've published. It's not the hardware is the problem. It's not the fact that people didn't have smartphones. It's a cognitive issue. It's about how you, myself, farmers, whoever, live their lives. People live their lives using gut feel, what we call gut feel, intuition, informed by experience, and every now and then bringing in some level of analytics, analysis. And so farming is a way of life for most family farmers. It is a business, true, but it's also part of everyday living. And you've got to ask yourself, when you get out of bed in the morning, do you go to your applications to tell you how you live your life, what you're going to wear, how you get to work, what you're going to eat? Do you use an app in your everyday living to decide how you live your life? Or do you use your intuition built from experience? And sometimes when you want to get to a place you've never been to, you use a GPS system and and Google Maps to get you there, but you don't use it just to drive to work every day. And so, this model up here is a model of human cognitive behaviour, and it's saying that we live our lives with this balance between intuition driven by experience and analysis where you're bringing in formalised analytics. And the key to what we're talking about here around digital agriculture is understanding when that analytics can play a role in decision making, can change the way that we think about a particular system or a particular decision. It's around changing our mental models about how the world works and shifting from one paradigm to another paradigm. I've put the paper there that those that might be interested in this thinking and understanding, it's been published. I don't know why that's, oh, it's over, it's not on the ones behind me. Okay, so a key other point that I want to make around this idea of ethics and trust in digital agriculture or in applied apps is the reality is that if you invest under risky circumstances, an increased investment leads to an increase in risk. That's a basic economic understanding. So if you want to increasing your returns, you have to increase your investment and likely risk goes up. And so, as I said, for a small farmer in India or in sub-Saharan Africa, what's their capacity to take on more risk? And what are we doing in terms of our innovation systems to try to de-risk? And so what we want to do is be able to create innovations that are going to increase the return without commensurately increasing risks. And that's difficult to find in particularly dryland farming systems. So again, another reality, when you're providing recommendations, you've got to understand asking farmers to invest in fertiliser might increase their productivity in 7 years, in 10, but it'll also increase the risk of losses in a certain number of years. So with that, I'm really pleased to be able to join my colleagues here and talk about this, I think, a really critical key component when we're talking about digital agriculture applications about the ethics and trust and how do you build trust in these systems going forward. So thank you very much. We're self-organised.
There was a question right there.
Someone at the back?
Hi, I'm Sarah, and I just wanted to say thank you very much. That was really interesting, and I think you've captured something that's been playing on my mind, particularly around risk and about how do you, I just wondered whether, Peter, you have some ideas on how do you communicate that risk to someone in a way that doesn't scare them off doing it? How do you actually really communicate? People need to understand, obviously, the risk that they're taking, and the risk, by understanding the risk, then they can understand whether it's the fault of something that they did, that their crop failed, or that was going to happen anyway. So how do you communicate that is the question.
Okay, it's a bit hard to understand here, but it's how do you communicate risk to farmers? It's difficult. I report on work we did in Australia, and Australian farmers are generally educated, and even there it's difficult to talk about risk in terms of probabilities. So the yield profit application we have there presents everything as probabilities, probability of exceedance curves. And talking about probabilities is difficult, so you have to have a whole training program around how do you interpret a probability distribution. These are decision support systems that provide definitive outcomes, so it's going to be wet or dry without a probability is problematic, because when your prediction is successful, then people say that's success. when you predict something to happen and it doesn't happen, then how do you deal with that? And what we did there in Australia was that whenever our forecast, the climate forecast or the outcome did not work, then that creates a learning opportunity. You can sit with those group of farmers to run through, well, why didn't it work? And they better understand their system, and that comes back to my point about that's learnt experience. That experience then forms part of their intuition. But, you know, so dealing with risk is dealing with probability. Can we do that the same with smallholder farmers in Africa? Very difficult, but we've had a go at doing that. But what's the alternative? You know, you have to, and I think anybody living and farming in this world understands that there's good years and poor years, and there's frequency about that. And it's about trying to map their own experience of recent history into what the learning might be around the decision support system. But it's a key issue. Do you want to...
We actually did not incorporate any risk component or like discuss the risk with the farmers. Obviously, like the risk of changing your traditional practices to adopt something new is the potential waste of inputs or losses in crops, or even just like failing at implementing the advice the way it was said, or actually even implementing it perfectly, but maybe there was like a rainfall came before, or like a change in the composition of the soil. And so there's like a lot of factors that are external. What I like to say, we did not discuss this directly with farmers, but when I talk about adoption, I often actually mean trialing. Because a lot of the farmers that I mentioned adopted, what they actually did, some of them, was that they tried the recommendations in a portion of their plots. So they actually did not do it across the whole plot. So they maybe just selected a small portion, and then they saw, and if it worked, then for the next season they know and they learned. If, for example, they saw it didn't work, but maybe worked with a neighbor, they could then discuss what happened. Maybe they did something wrong, maybe they actually didn't, it didn't work for anyone. And so like that, it's like kind of like, as you were saying, a learning process, and you start to adapt and update your expectations on how much inputs to use. And so for this, in this case, it was actually very simple practices. So it was like pretty much guaranteed that they were going to succeed. And so it was like mostly successful, but some farmers just tried it on a small portion of the plot just to ensure themselves. And so I think like here risks were internalized by farmers and they managed them on their own. But it's great to know about like other platforms where actually there are proper predictions and adaptations. Do you want to add something else from digital green perspective?
We can see if there's more questions. Do you want to see if there's more questions, Brian?
Any more questions?
Well, I think that one of the takeaways of the amazing work that Digital Green has been doing is that sometimes the technologies that work better are not necessarily the highest level technology, meaning there's a trade-off between impact and scale. And sometimes, you know, you have to use a diversity of solutions. My question for the three of you is how to help, especially public sector institutions, to bridge that gap. Because social enterprises and private sector will get to some point, but that there is like some underserved market that the public sector will need to get to. So how to put the power of what you've been doing into their hands?
Yeah, I mean, I can try to answer part of it. I think the way we think about it is there's lots of different types of so-called platforms that exist in these farming communities. There's the informal sort of social networks that farmers already have, like in the absence of all of us, about learning and sharing with one another. And then there are the more structured types of community mobilization efforts that various types of government and civil society organizations are often involved in. And then there are like the private sector kind of folks. The role of digital potentially is, that we've been able to see, is how that can serve as a base layer for private sector sort of like startups and other agribusinesses to more easily reduce the transactional costs of engaging with these underserved types of communities, with whom there could be at times opportunities for linkages, right? Of like, for instance, producers with supply chains that could give them a higher return for their harvests. But you know, a lot of people have over history, of course, have talked about all these like public-private partnerships and all that, and of course most of them have not really panned out when you kind of force a very strong connection. But that's what the power of data potentially is. That if there are a common set of farmer and farm identifiers, for instance, that people can build applications on top of it, right? You could start with the farm and farmer identifiers of government sort of large-scale programs which have the most massive outreach than any private sector kind of initiative. But then you're able to have private sector and other kinds of organizations build their own applications on top of that base that has an opportunity of a lot of sort of synergy between these two groups. Even if you think not just even between private and public, but even between research and extension, right? The never-ending saga of how do you kind of close the gap between researchers and extension? Well, instead of like forcing those collaborations, which sometimes happen on a one-off basis when they're funded by a donor, for instance, if instead you had extension services collecting data on a common data standard that research was able to tap into, now you could have a more two-way exchange between these often fragmented communities.
I mean, that was a very good answer. I think there's like a lot of focus now moving into local partnerships to make as well solutions not only impactful but also like sustainable. I think I totally agree with what you said about the data, and in our specific project we're now looking to scale up the solutions, and one of the challenges is to find private partnerships, but it's not too much to get them involved and interested in like targeting underserved markets, which can then obviously with like international organization we can raise funds and make basically those markets easily accessible. But it's more in terms of how we're going to market the products, because in the end like private firm wants to do things for profit, but sometimes in international development the scope is to give the services if possible for free or at a very lower cost. So I would say the challenge sometimes is more making it like profitable and sustainable at the same time while engaging everyone and all cross-sector partnerships. So that's not really an answer, but just a thought. I don't know if you want to add anything as well.
Look, I lead an institute at the moment where that's a key issue about how do you get to scale and how do you do it efficiently, what partnerships you have. And so it's a key agenda item and a key issue that we in this community have to address. My frustration is that what I see is a lot of re-apostrophe search. It's people doing the same things over and over again in case studies, and there's not much learning happening. You know, we in research organisations should be in a place where we can triangulate between what the theory is saying, what other people are doing and what we're doing, and learn from that, so that if we're going to implement another program, you know, we've learnt from that. We're trialling things that we think are going to work based on that theory and learnings, not just from, you know, we think it's a good idea type thing. So I think that probably if I was going, well, I mean, as I said, I lead an institute now. The investment that I want to make is not on more case studies. I want to do less case studies. I want to do more around learning from what we're doing and what our partners are doing with digital green, with the private sector, with other activities.
I think we're going to wrap up so we can turn the room around for the Inspire Challenge, but I think this might actually be, I sometimes you know, think it's a little bit, sometimes it's valuable if you ask for a simple answer to one question. And so if we could go across the panel and just say in a very short phrase, what do you think is the kind of constraint factor or the piece to manage where we can build these trustworthy, ethical digital advisory services? What's the key focus area that you, if you have to pick one and advocate for it in just a short phrase across the panel, and I think we can wrap up from then.
I think we have to be realistic and tell the outcome as it is and not be promotional about trying to, we're more concerned about selling the product or the service without actually understanding that the message carries risks, there's probabilities of failure, and that probabilities of failures have to be quantified as much as success. So being truthful and realistic in terms of what our offer is.
I would say that it is perhaps also accountability and attestation around the quality of both data and content as being sort of a base primitive that we as a community need to kind of agree on. What are those standards that we are willing to agree are like a minimum viable product of like being able to share and learn with one another. The fact that we have so many fragmented and often reinvention of the wheel sort of processes, I think is a real hindrance for our sector to grow.
So what I see currently like as a limiting factor in the short term is that we're very fastly moving to like digital technologies, but the truth is that those technologies are not integrated yet in all developing countries and markets. So it is true that it is growing, but there is still like a gap, and there's like a lot of research at the other end of like innovation and using a lot of like technologies, and yet there is still like a lot of rural communities who are not completely like into this like trend, so like they're not moving as fast, and while they're getting there is like kind of a gap that it's forming, and so it's a challenge to try to like close it, because technologies are growing very fast, but the interest that people have in technological products advances a bit more slowly. And so I think it's more, for me, I would say like the main focus now is try to bridge this gap the best possible and create products that are actually going to be practical and useful from the point of views of local needs, and yeah, so basically adapting it to different markets and different cultures as well. Thank you very much.
Fantastic, thank you. So let's thank our panelists. And
So just so you know the next sequence, we've got a quick coffee break, and then we'll be starting the Inspire challenges at 4 o'clock. Why? So brief coffee break and then come back. This is going to be the good bit. This is going to be really fun.
Hello? Okay. Great. Inspire challengers. Hello, hello. How are you guys feeling? Good? Okay, great. I'm gonna have you come up. This is the order that it's going to be in. I want you to make sure your slides click through, okay? Make sure your audio and your videos play. And once you are done, then you're gonna move on and the next person's gonna come up. We're gonna have to do it very quickly. Does that sound good? All right, can I have Hungry Cities? All right. Take a look at this. The green button is to move forward. This red button is to move back. This firework, your Sampat screen. Great. All right. Let it rain. ऑन नहीं है Okay.
I have an umbrella to protect myself from the sun and the heat. I don't have my umbrella just in case.
It's loud enough out there? Can they hear?
It'll go, the volume will go up. Yeah, don't worry. All right, so you're gonna have to go back and tweak that. That's okay, we have time. That's why we're doing this. If you'll just wait for me back there, I'm gonna have the next people go. All right, slam. Wait for me there, we have to go through the power. You're just so simple. Thank you. Lovely. Clear insights for healthy fish. And next, climate information services. Ram, you're next. Good? Great. Hand it off. Lovely. Good. Okay. Farmer's friend. Farmer's friend.
Am I pitching now?
No, you need to just slide through. Just go through the slides and make sure it works. Green is forward, this is back, and that is the pointer. And there is also up there. Okay, quickly, because we have to get through more. Just you're checking that the slides work. Great. Thank you, Kofi. All right. Show me what you eat. Mm-hmm. Great. Thank you. Citizen H2D3.
What's the button to go through? The green?
Green.
The big one, yeah?
Yep. And then real-time East Africa groundwater and one village, one mill.
We all need balanced diets to lead healthy lives.
They are
But
going to
this-
the volume. Yeah, we were just clicking through to make sure everything clicks. And I'll explain the speed. That's the back. It takes a minute, but it will go back.
I'll try to size perfect.
Okay, great.
Thank you very much.
Sorry. Groundwater?
Oh, sorry for that.
You're fine. Okay, I'm gonna just need you to click.
Yeah, I just want to make sure that the first animation starts, and then
Okay.
it's fine.
Great.
Yeah? Oh, yeah.
There's a screen up there.
Okay.
Here you go.
Okay, I just need to make sure that the video, because now it's the video, so I just need to make sure that it starts on its own. That's not going to click, so sorry. You have to wait 10 seconds. Sorry. And the video, yes. Okay, perfect. Yeah, perfect.
One village, 1 mill. Sarah? Great. All right, while Sarah is clicking through, reminder, the green arrow is to move forward, small red arrow is to move back. All of your slides are going to be on this presenter screen right here for you. Okay? Sounds good? Sampath, kya kar rahe ho? What are you doing? Test, 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 test. All right, I'm gonna. You're gonna be using it like this, not like this, not like this, like this, like this. They are on.
Judges say that they're not going to do it in every one, but if they have like a question that they absolutely need to ask, they have 1 minute to do it at the end.
At the end of each presentation.
And you have to, so it's going to be a very short question, it's going to be a very short answer during the changeover, and then they can follow up with you if they need to. But if they, it's kind of like, I've encouraged them not to.
ये माइक दोनों को बंद करो. एक और माइक. हेलो हेलो. ये माइक सामने में रहेगा, ठीक है? इसको हेलो, इसको बंद कर दो. Check.
Okay, are you ready for the Inspire Challenge? Okay, let's get some clapping, some shouting to bring everyone in. Can we have some inspirational music?
अपनी भैंस चराए आज की रात है कल से वही से पे है जी भर के नाच लो ना घर वाले ना मापे हैं क्लब पे अपना राज है डरने की क्या बात है ये तो बस शुरुआत है ये तो बस शुरुआत है अरे अभी तो पार्टी शुरू हुई है अरे अभी तो पार्टी शुरू हुई है बाद में ना कहना कुछ भी पहले ही दे दूं वार्निंग पार्टी चलेगी टिल 6 in the morning जी भर के नाच ले बेबी नाच नाच के तोड़ दे सैंडल आंटी पुलिस बुला लेगी तो यार तेरा कर लेगा हैंडल
Enough. That's great. All right, we got. There's nothing like a bit of Bollywood to get in the mood, right? So the time has come, the Inspire Challenge. So we've got 10 very nervous people here at the front. We have 4 judges who are now going to be revealed. They've been I've been getting all sorts of questions from people in the coffee. So who are the judges? They've gone, when I refused to disclose, they went to some of the other organizers. I don't know how successful you were, but now we have these judges that are going public. And so this session is going to start. So first of all, what I'd like to do is, there's a point where I have to get serious and be very objective and not show any emotions, which is very hard for me. But before that, let's get the emotions out. And so I'm interested in hearing the human side of this process, because I spent most of yesterday over at the booths, and I mean, the decibels was just continuous. It was a nightmare because I was trying to do some filming, and I couldn't get really good sound just because of all the chatter that was going on, right? So it was great, and I saw people start out incredibly enthusiastically, and there were some faces at the end. It was like, oh, I need a beer. So I'm curious. Let's hear about the human side of this. In 1 or 2 words, how was this process? So let's start with the Inspire challenges. Anyone want to share a word?
Test. Okay, there we go. A word.
No joking. This really was inspiring for me. Seriously.
Oh, that's what we want to hear. We planted that one. No.
It's been amazing to share lots of ideas, but my brain feels like it's been milled.
You better wake up.
Yeah, so all the energy in the room really kept us buzzing and getting us very pumped, yeah.
What can I say? I thought it was real good.
Oh, that's cheating, that's cheating. Anyone else want to share? Yep, Kofi.
Let's just get on with it.
So yeah, for me it's been great meeting all these amazing people doing amazing stuff, and I've been inspired all the way.
Nice. Okay, Mark?
He was an amazing partner in this project.
Yeah, no, after going through this process, I'd actually like to do a mashup of a bunch of the finalists into one project. That would be really exciting. Very inspiring.
Oh, nice. That's a nice idea. All right. Anyone got $1 million? Judges, how's this been for you? Brian.
I have the mic. Sorry. No, it was fantastic. It was a really nice listening to all the projects and all the energy they have.
put on to get here. So, and we also have started having fun with the rest of the judges. So I think this is going to be amazing.
Yeah, I think it was a lot of fun to interact with the contestants and talk with everybody and find out about their projects. Really good projects. Looking forward to the pitches.
I would say invigorating. It's nice to get out of your office and email jail and hear from colleagues and the exciting work that they're doing.
Yeah, I think for someone who's a little bit newer to the agriculture space, to see the innovation and seeing all the projects that you're clearly doing to help people and to really build systems of trust and try to, really contribute to food security for the world has been really fantastic. So great work, everyone.
Right, who says that agriculture's boring, right? From the crowd, anyone got something about this experience? How was it for you lot? Anyone really interacting there at the back? Kate?
So I'm stealing a bit as a judge, but just from the judges group, it's been incredibly difficult. That we get more and more applications every year, and it's wonderful, and to choose among them is harder and harder, and that's really a good sign. And I think this is the most exciting event the CG's put on every year. I think it beats the snot out of Science Week. I'll just say that out loud.
Okay, any more? I'm gonna make it hard for the man with the camera there and move around a bit.
So they say that agriculture is going to be the coolest profession in the world in the future. I'm quoting a futurist, Thomas Frey. I think being here, you can see that it's going to be the coolest profession.
That's good to hear, good to hear. Any final words before we get going? All right, okay. So, let's start kicking this off. Are you guys ready? Well, the Inspire challengers certain are, but what about the rest back there? Are you guys ready? Better. Okay, so the format for today. We're going to have each challenger, they know the order, and they're going to have 5 minutes to do their pitch. Is Harold in the room? Wing! Yes? Yes, we've got Harold. Okay, I'll be picking up Harold, and Harold will be signaling the end of the 5 minutes. We have Matt down here with our beautifully drawn 1, which means 1 minute left, and he'll be waving it, wafting it in front of you, okay? What I'll do is just subtly get up on 20 seconds, and I'll slowly walk towards you, and then I'll sound Harold at the 5 minute, okay? I personally am really hoping that Harold gets some action this afternoon. I feel like there was unfinished business from yesterday. But I know it's not in your interest that Harold gets some action, so let's see. The judges, we're going to introduce the judges in a sec, but the judges will have 1 minute if there's a burning question, okay? So the lack of a question doesn't mean anything, but if they have a burning question that they just want to ask, there's a 1 minute little period at the end to do that while we're doing the changeover, okay? And then the judges can also follow up and ask, follow up on stuff if there's still outlying issues, just one-on-one at the end. Okay, so over to introducing our judges. And so we have, first up, we have Ana Castillo from IDB Labs. You want to stand up, Ana? Round of applause for Ana. We have Cheryl Porter from the University of Florida. We have Caroline Flory from IRRI. And we have Courtney Heldreth from Google. That's our illustrious judging panel. Okay. Are we all ready? Everyone clear with the instructions? Anyone want to pull out? Okay. So let's get going. The order is, first up we have Hungry Cities. Okay, we need another mic up here, do we? You've got the mics, you ready?
Yeah, do you want your phone?
Yeah.
I can read your phone for you if you want.
Okay.
Yeah.
Just in case, let's leave this here in case you want to use it. Okay, ready, go.
Good afternoon, everyone. My name is Joram Kabach from Twiga Foods.
And I'm Mark Lundy from Seattle.
Just a brief background of Twiga Foods. Twiga is a business-to-business social enterprise that was founded in 2014, meant to supply fresh foods and vegetables to the population in Nairobi. Together, we want to collect and analyze data that will help us understand the consumer and wholesale markets, fresh food flow and consumption. Twiga Foods currently has a vendor base of 14,000 people, of whom 70 are women. 70% are women. We have a farmer base of 20,000 farmers across the country who supply us with fresh food and vegetable. Let me tell you about Nairobi. Nairobi's current population stands at 4.5 million people, 60% of whom live in slum areas. 85% of these slum dwellers have deficiencies in food and nutrition. We believe that this can be solved by supplying them, consuming more fresh foods and veggies. And these dwellers also access their food from traditional market channels. And oftentimes, these channels are not as available. Twiga came in to solve this gap, to fill this gap, and we currently supply up to 90 to 100 tons worth of produce on a daily basis to our vendors. Annually, that means you're supplying up to 25,000 tons of produce to our 14,000 vendors. That is close to 2.5 million transactions annually. The model already has its efficiencies, some of which include stable food prices, because we offer our farmers contracts and our vendors, we offer them up to 15% discount on the supplies that we give them. We also have minimized food loss to between 2 to 3% compared to the traditional channels, which still record as high as 15% losses. The model is profitable and growing, and we believe that we can make it more optimal.
So, Joram, that's pretty exciting. You guys have a really great model that's doing a great bit of social justice and providing food to lots of people. But you know what? People are probably asking, where's the app? Where's the drone? Where's the robot? Where's the big data convention? And I think we need to be clear. The innovation that we're going to add value to here is the business model. So Twiga has the innovation. We're going to apply data science to supercharge this business model in two ways. So building on the data collection that Twiga is already conducting, the 14,000 vendors, the 20,000 producers, we're going to work together to do two things. First, we're going to improve data capture of information on wholesale markets to understand what fresh fruit and vegetables are entering Nairobi, from where, what volume, what quality, at what price, to optimize Twiga's pricing model. And as a result, maintain their competitiveness vis-a-vis the traditional market. Given that they have greater efficiencies, that will benefit the final consumer and the producers. Secondly, and perhaps more importantly, we'll take a subset, a sample of the 700,000 families that are currently serviced by the Twiga business model, and we'll work with a 5Q questionnaire to understand what's their status of knowledge, attitudes, and practices about fresh fruit and vegetable consumption. Why do they consume and why don't they consume? And based on that, we'll then optimize the promotional materials for working with these consumers. So if you invest in this Inspire call, we'll deliver an improved, optimized business intelligence unit for Twiga and an optimized business model that can scale profitably. We'll deliver greater insight about how to provide fresh fruit and vegetables to low-income consumers and fill the nutrient gap and market failure. And we'll roll this out with Twiga across Eastern and Southern Africa, starting over the next 5 years, moving from Nairobi to Mombasa to Dar es Salaam and Addis Ababa. So this will help answer the question of how do you feed nutritious food to growing African cities. Thank you very much.
Okay. No questions from the judges on that one. Harold, he's sad. Next up, Let It Rain. Okay, you got your mics? Okay, ready? Go!
Good afternoon, everybody. So welcome to our presentation, Let It Rain, with the main concept being gamifying weather information and farmer engagements. My name is Kevin from Media in Nairobi, Kenya.
And I'm Evan from Cgiar, Africa.
Now, I come from an organization where the most frequently asked question is, when is it going to rain? And even if farmers get a few drops of rain, they tend to ask, when am I going to plant? Is it time to plant? And due to that, it is very critical that farmers put the seed on the ground at the correct time relative to when the rains begin. However, we are all aware that rains do not begin at the same time. And therefore, during the planting period, farmers are thrown into a state of confusion. And this is because different crops have got different planting windows.
So our solution is to gamify weather information. And we're going to do this by working with a popular TV program in Kenya that's linked to an agro-advisory mobile platform. What we're going to do is we're going to challenge farmers to guess when the rains will come in their village. And if they guess correct, then they win a prize, including being signed up for a premium version of the agro-advisory platform. And you know, this is not about really the prize or the game in itself, but really it's about getting farmers engaged in this platform and starting a two-way communication with them. So how we're going to do this is we're going to work with some partners. First is a gaming company called Usiku Games, based in Nairobi. They're Africa's first social gaming studio. We're also going to work with agricultural research organizations, Cgiar, who I work for, and KALRO, the Kenya Agriculture and Livestock Research Organization. We're going to analyze the weather data from weather stations, from satellite imagery, and determine when the rains start in every village in Kenya. We're also going to provide climate risk analyses for specific places and value chains throughout Kenya, and agro-advisories for those climate risks, which can be integrated into the advisory platform.
The third partner is Shamba Shape Up. Shamba Shape Up is the biggest and most popular agri-TV show in East Africa. Shamba Shape Up has a viewership of 8 million plus viewers across Africa. Under Shamba Shape Up is iShamba mobile platform. iShamba mobile platform has 300,000 active mobile users currently. It is an agri-advisory service that helps farmers with weather data, with market prices, and other advisory services. So we are going to demonstrate how this game will work. So the idea is to
I have an umbrella to protect myself from the sun and the heat.
And I have my umbrella just in case it rains.
It's not going to rain. It's hot.
I was told it's going to rain.
No.
Are you struggling to know when the rains will start? Have you started planting your maize and the rains fell short? You are not alone. These are real problems all over Kenya. This season, the Shamba Shape Up team will support you to plant according to the rains, so you can have a better harvest and income and more food for your family. We are starting a competition across the main growing counties in Kenya. All you have to do is guess when the rains will start in your area, and you can win up to 100,000 shillings in your county. This is how it works. Send the word RAIN to 21606 on feature phone or smartphone. Fill in the basic details, including name, location, and phone number. Give us your best guess for the rains. And done! You can guess more dates by signing up to iShamba or telling us more about your farm. We will send you advice on when to plant, how to manage your crop, and how to get better weather information in the future. Each county will be awarded 100,000 Kenyan shillings. You could win it all or share it with other winners in your county. Sign up now and secure your chance to win this momentous prize.
So some of the benefits that we see coming from this are, first, that we can educate farmers through this two-way communication on the value of weather data and help them optimize when they plant their specific crop based on these agro-advisories. We also will push out risk reduction practices to them that they can do based on the weather that comes in the given season. We'll also be aggregating information through them, using this game as a way to incentivize them to give us information on their profile and on whether they see if it rains or not in their given farm and the risks that are there. And finally, we can use that to validate weather information and risks.
In a nutshell, we are building a multimedia ecosystem. The crowdsourced weather data is going to assist us to be able to improve on targeted agro-advisories. And in future, we are looking at building new social games that will help farmers, even gamifying even the real advisory services. And we're also looking at scaling out to even other countries. Thank you very much for your time.
You missed it by 2 seconds there, Harold. Judges, question? Just stay on the stage for a second. I think we have a question. This mic?
Don't take Harold. No, I have only one question. What is your income model?
All right. So iShamba is a mobile platform which has two versions. There is a freemium model and a premium model. So a premium model is where a farmer gets advanced advisory services and they subscribe by paying like $5 for a whole year. And also we are working with commercial partners. So a commercial partner will come on board and then they can be able to pay. For instance, if a farmer buys a product, then the partner is going to pay a premium charge for this farmer so that he can be getting the advisory services. It's working very well. Currently, there are over 15,000 farmers on the model, and it's picking up really nice.
And just to add to that, there's also corporate agreements that are being made where if a company has a group of farmers that they're working with, they can develop an agreement for that many farmers, or GIZ as a development organization also can do that type of thing as they have.
Thank you very much.
Okay. Thanks a lot on that one. Let it rain. Okay, next up we have Slam. Do you need these two?
Yeah.
Those both working. There's your pointer. Ready? Ready, steady, go.
Okay, hello. We are Slam, and we are promoting a self-learning platform for farm managers. And the idea of the self-learning, that it's on the platform, not on the farmer, and I wanted to make that comment first out. So, to start with, I want you to do something very dangerous here, which is we're going to close our eyes for a minute and imagine you're this farmer walking in the field. So you feel completely relaxed now, you feel completely relaxed, you're walking in your field, in your nice crop, you're walking there, and suddenly your phone rings. What's happening? There's a guy asking you about weather forecasts and whether it will rain. You answer that thing, you walk more, you walk through your field, bam, again your phone rings. Now it's a voice message you're listening to on your fertilizer advice. And this continues and continues and continues. So your nice walk in the field is becoming a stressful activity. I hope you felt a bit of this stress when you were closing your eyes. So what it means to us is that it's for the farmer, it's a chaos. It's many apps all doing one thing, maybe on weather, maybe on disease, maybe on nutrient management, maybe on irrigation. And it's one directional. We tell you or we extract something from you. So we want to solve this by doing SLAM, which is a self-learning platform to have a continuous conversation with the farmer where we will learn from him how to make a better advice. We do this based on agronomy, based by building on the science that Cgiar helped develop in an interactive way, and we want to go for full crop cycles for one app per farmer to kill the many apps on the farm. So we do this by combining 3 innovations we already have. So our main innovation is combining these, and you see 3 things. One is the AgroMed service we are running to make advices to farmers using voice, SMS, based on a crop growth model and growth conditions during the season. The second is from agroforestry and forest management and community management, where people can give feedback on deforestation, and we will tune that to agricultural advisories. And the third one is to do text mining on newspaper articles in Indian newspapers to find out how current conditions can change the advice on a larger scale. So what we want to achieve for that, and this is the future we see ahead, if we've developed a prototype next year, we are aiming to reach 5,000 farmers. Next to that, we want to outscale the year after through the networks we have through our AgroMed service in 3 countries, Ethiopia, Bangladesh, and Myanmar. And we want to reach the full scale of IFCO, Kazan, our partner, will raise 2.4 million farmers on their platform. Also, we want to demonstrate the added value of incorporating Cgiar's data in these type of services. to make sure that we are running, that we show what Cgiar can really do. Now, this is the team that will make this happen. We brought in CIMMYT and CCAFs, who collected a lot of data on rainfall, on agricultural trials during the years, and on climate change, on weather information, and how all that works together. We are both from Wageningen, me, Sanne Jansen, and Allard de Wit, and we worked with small advisories with agronomy and the crop modeling. And then we brought our colleague Arun Kumar Pratyas, who is Nepalese, who works with the forestry management side. Finally, we have three partners who are not where Paresh was here these days, who work really on making the links to farmers, doing the trials with the farmers, and having those connections. So what I want to close with is a call to action for the judges to ensure that we can do this next year and realize the prototype. And a call to action for all of you to help us realize this dream and help us with additional cases. I already talked to 2 very promising cases at this conference to reach scale fast. If you have initial data that can help us to do this, then we're really looking forward to talk to you. And finally, I want to leave you with a question, which is this one, which is a fundamental question to what we are all here doing. Do you really want to empower the farmer? Thank you.
Okay, no questions from the judges. On to the next one. Clear insights for healthy fish. Are you guys going to do a double act? Okay, round of applause, please.
Mic drop.
Stop.
Again? Start again?
Okay, ready, steady, go.
Good afternoon, everyone. Andy and I are here to show you how we will use the latest sequencing technology coupled with machine learning to vaccinate fish for small-scale farmers. And we are hoping to hear Harold only when we finish this talk today. According to the United Nations, food and nutrition security is achieved if adequate food in terms of quantity and quality is accessible for and utilized by all individuals at all times to live a happy and healthy life. Fish realization target of this goal very well. It's a good source of high quality protein, but it's also high in iron, vitamin A, and iodine, all critical in childhood development, and are deficient in many staple foods. As fisheries are mostly fish to capacity, as you can see on this slide, production has remained static since the mid-1980s. So the increasing demand for fish is being met by aquaculture, one of the fastest growing food producing sectors in the world. Indeed, 54.1 million tons of finfish were produced in 2018 via aquaculture, generating over $138 billion and employing 19 million people, with a majority of these in the developing countries.
Disease is the major constraint to aquaculture growth and is currently the focus for the United Nations Food and Agriculture Organization Subcommittee on Aquaculture. Current disease mitigation strategies in developing countries mainly comprise overstocking to compensate for losses, which actually makes the problem worse, or use of antibiotics to treat the diseases, which actually causes antibiotic resistance. Antibiotic resistance mechanisms found in fish pathogens are the same as those you find in livestock pathogens and human pathogens. So it underlines the importance of including aquaculture in a One Health approach. But we've seen this problem before. 30 years ago, during the development of the Norwegian aquaculture industry, 50,000 kilograms of antibiotic was used in 1987 alone to treat disease in Norwegian salmon. But we fixed it. How did we get from here down to here with almost zero antibiotic use while the industry continued to grow? We started to vaccinate fish. There are challenges for introducing vaccination programs in warm water aquaculture. The market is fragmented amongst tens of thousands of small-scale farmers, farming multiple species of low economic value, Warm water fish ponds are rich microbial ecosystems with huge pathogen diversity that changes through time. And yet, we still vaccinate under these conditions successfully. And we do it using locally produced, custom-made vaccines applied per season. But these require rapid, high-resolution strain typing in order to formulate the vaccines and deploy them optimally. During disease outbreak investigations, aquaculture inspectors take samples from the farm and bring them to the lab. Our project adds a genome sequencing component to this. Until recently, this was too expensive, time-consuming, and required sophisticated laboratory facilities. With the advent of nanopore sequencing, this changed. Using these small pocket-sized devices that are cheap to buy and don't need sophisticated laboratory facilities, I do all of our sequencing in my office because it's cool to watch, we can actually generate sequence data in real time, but the data that it generates is fuzzy. We can't get the high-resolution strain typing information that we need. Our innovation adds a cloud-based machine learning stage into this through our partners Wilder Lab in New Zealand. This enables rapid strain typing that enables us to feed information back to the aquaculture inspectors who can formulate biosecurity management plans for the farmers. It also allows us to specify vaccines that can be formulated and produced locally and then used to vaccinate stock going out onto farms with all of the same pathogen types, thereby securing the next crop, reducing the spread of disease from farm to farm, and reducing the need, in fact eliminating the need, for use of antibiotics.
So these big data-driven but locally implemented solutions that Andy just described align well with FAO recently proposed management pathway for improving aquaculture biosecurity. If successful, our Inspire project will provide information that can be accessed. Thank you.
We wanted to hear Harold.
Okay, judges, any questions on this one?
How will you make this project self-sustainable?
Two ways. I think the most obvious way is your locally produced, your locally based vaccine producers. We have a profit share model with them because they use the data that we collect. The other thing is that because we're doing whole genome sequencing, the resource of data that we collect is enormous. Whilst we leave the biological resource in country, it's very important to do that, we have the genomic resource available to us, and that's quite valuable because not only do we get the strain typing data that we want, we can build epidemiological models, but we'll also get all the antimicrobial resistance data, and that might be interesting to large organizations like World Health Organization, etc., who might want to pay a premium subscription model if we put this into a dashboard, a usable dashboard.
Okay, thanks a lot. Next up we have Climate Information Services for Resilient Livelihoods. Okay, get yourselves ready. Do you need a mic?
Yeah.
All there? Yeah. Okay, ready, steady, go.
Good afternoon all. My name is Ram Dulipala and I have my team here. Our Inspire challenge is titled Climate Information Services for Resilient Livelihoods. Judges, one of my colleagues just gave you a phone with an SMS, and these SMS goes out to about 40,000 farmers on a weekly basis, right? Anyway, let's jump into the pitch. Agriculture and dependent livelihoods are at climate risk perennially. I think we all agree with that. But climate information services can build resilience of farmers and food systems. But there is a huge but there. Most climate information services are not location specific, are generalized for all crops and soils, and fragmented, leading to an information overload. Net result is disadoption of climate information services by farmers. And there are two big trends that I want to draw your attention. Increasingly, weather forecasting agencies are deploying more and more computing power and deploying better methodologies, so their forecasting abilities have improved. They're also coming up with better information products like seasonal climate forecast and extended range weather forecast. The scientific community is increasingly coming up with a lot of good crop simulation modeling. The question then is, how do we use these advances in two distinct fields in upstream science and create a product that essentially answers those three constraints that I just described. Fortunately, we just did that through a project called Intelligent Systems Advisory Tool, which we did in collaboration with Angru and with Microsoft for the groundnut growers of Anantapur district. One SMS of that you just saw on the phone that my colleague gave. As part of this project, our project team used a combination of crop simulation modeling, data analytics of historical climate data, and they also did a lot of focus group discussion with farmers and understood how farmers perceive weather, what are the kind of decisions they make in relation to information services, did a lot of analytics, blended all that information into a decision tree. You see this pictorial here, the picture at the bottom. It's kind of a visual map of the process involved in development of ICRISAT. And finally, the output of that is a very contextualized advisory, like the one you just see on the phone. So we don't tell the farmer it's going to rain. We tell the farmer, if it's going to rain, you do this. If it's not going to rain, you plow the land. So it's a very contextualized and very actionable advisory. The challenge of ICRISAT, of course, is upscaling it. How do you take it from 40,000 to, say, 300,000 farmers? That's where our real innovation is. We propose to use a combination of gamification and machine learning to upscale the ICRISAT platform that we already have developed. How do we propose to do it? We propose to leverage the partnerships we have with the Indian Meteorological Department, who will supply us the historical data, the Indian Institute of Tropical Meteorology, which will also supply us the data. We propose to bring in Dr. Ranveer Chandra of Microsoft, an ML and an AI expert, to support us around the machine learning. And we propose to use Angru, represented my team member here, to bring in the expertise around crop science. What is it that we propose to do? We propose a game for them, where different weather scenarios are randomly thrown at them, and then they are asked to come out with crop-specific advisories. They will also be given some training around the use of crop simulation modeling, data analytics, at the time of them devising the advisory. The advantage of bringing people who are actually working on the ground is a lot of times there is a lot of subconscious and a lot of unarticulated tactical knowledge which some of these agro experts already have, which are very, very contextual, very, very localized. Through gamification, we hope that when they come up with an advisory relevant to different weather scenarios for different crops, a lot of these unarticulated and subconscious elements important to decision making shall also be captured in the game. Once we have all those responses at the end of the game, we have recorded all of them in a database. We propose to do machine learning on top of that data so that we are then able to come up with district and crop specific algorithms. For Anantapur groundnut, it was decision tree. Maybe for a Chittur tomato, it could be a random forester. It could be any pattern. Once we have those algorithms, we already have the ICRISAT platform in which these advisories will be, this logic will be encoded. And so the automatic messaging system will start throwing out actionable advisories to 300,000 farmers across 30 districts. That's not the only outcome I'm speaking about. This methodology kind of gives us a template on how we can blend high-end science like crop simulation modeling and data analytics and create a seamless, contextualized advisory system. I think that is the real takeaway from this Inspire proposal. I'll pause there. Thank you.
Okay, any questions from the judges on this one? We have a question.
We are asking the same question, but I think it's important in order to evaluate is what is your income model?
Yeah, that's a great question. One of the partners we have is SourceStress, which is a commercial ag tech player catering to about 1 million farmers. They are into the B2B space. Companies like Olam are paying customers to them. So for us, it is very easy to pivot this into some kind of a paid advisory service through some of the existing customers he has.
Okay, thank you.
Thank you.
Next up, we have Farmer's Friend. Do you need this? They're getting their sleeves rolled up.
Sorry?
Okay, ready.
Yeah, hi. Hello, everyone. My name is Yofi Wood, and I'm from Limitless AI. I'm here with my colleague, Dr. Ibnu from Africa Rice. we are here to present to you Farmer's Friend. Farmer's Friend is an expert agric extension officer and a dynamic farming encyclopedia in the palm of your hands. Now, what is Farmer's Friend once again? Imagine a single internet-free device utilizing AI, user data, user location, all in a dedicated mobile device, informing a farmer the best times to plant, the best crops to plant, the expected weather patterns within a farming season, helping a farmer identify the pests and diseases, giving a farmer a prediction on future market prices, and all other activities from the start of the planting to the end of harvest. That is Farmer's Friend. And this being delivered through a voice output in English or a local language in one single mobile device, which is internet free. Now the problem and the solution. We are all very familiar with the problem of limited agric extension officers to farmers, the inadequate farm practices being utilized by some farmers, the emerging different crops and different crop diseases and pests moving from country to country, and the era of change in climate, which is affecting the current farming practices. Our solution is Farmer's Friend, utilizing multiple AI solutions to deliver actionable insights to farmers in video, text, and audio in one mobile device. Now, the main features of Farmer's Friend, we have predictive analysis where we are giving insights on the weather patterns, the rainfall patterns, the future market prices. We are utilizing computer vision to allow farmers to identify pest and disease on their farms by just taking a picture of a pest or a disease. We are having an interactive chat agent a farmer could interact with, get educated on, and we have a knowledge resource base where a farmer interacts with it from day one and is guided in all his farming practices. Someone may ask if a mobile device could support all this, but one thing that would blow your mind is a smartphone in 2019 is 100,000 times more powerful than all the computers NASA used to send the first man to the moon. Now, the partnership behind Farmer's Friend. We have my organization, Limitless AI, partnering with Africa Rice. Limitless AI brings on board their technical expertise in developing agri-solutions for farmers back in Ghana. We have AI and expertise. We have been designing softwares for people. We have Africa Rice with their agronomy expertise. They have a legacy in advising rice farmers across Africa. They are currently working with over a lot of farmers across Africa. Currently, we have Farmer's Friend MVP version 1 and then MVP version 2. We are actively working on MVP version 3 for next year. And then Farmer's Friend will be accessible via USSD and SMS. Now, our inspiration in China, they had agri-science students stay with farmers and then offer advice on simple things like when to plant, how deep to plow, which seeds to select. And China saw a national increase in their wheat and maize averages based on these advices these students gave the farmers. And last year, we also developed a predictive analysis tool that helped farmers identify the areas fall armyworms would attack. And in doing that, we realized the power of AI. And since then, we've been further developing more AI tools for farmers. Now, our business model we have where we are selling Farmer's Friend to a government. A government distributes Farmer's Friend as a device to the farmers in the country. We have a model where there's those who buy crop produce in bulk, distributing to their farmers. And we are working with other partners in the agric organization space who would franchise Farmer's Friend and sell it to their farmers. Now, traction, we are talking with our ministry back in Ghana, which has 128 million allocated fund for a project they call Planting for Food and Jobs. And they've told us once we are ready, we should come. Isoko Crop Advisory Services Ghana is interested in what we've been doing and have asked us to sort of give them our software for their own cheap smartphone devices. The price as low as $49 as high as $79 comparatively. The cost of 50K fertilizer bags. We are making it accessible for all women farmers. And we have support from DigitalOcean, Amazon, and Google in form of support and cloud services. Thank you very much.
Thank
Thank you very much. Judges, do we have a question on this one? No questions?
Good.
Okay, thanks a lot, Farmer's Friend. No, it's not. Okay, next up we have Show Me What You Eat.
Hello everyone, my name is Manuel Hernandez. By the way, I'm still waiting for your meal pictures, maybe tonight at dinner. So this idea, it's a joint effort with other colleagues in IFPRI, also the IFPRI Nutrition Lab at Washington University in St. Louis, and Universidad Mariano Galvez de Guatemala. No? It's Show Me What You Eat, assessing diets with images. So the overall objective of the study is that we want to use daily meal pictures to assess and improve the dietary quality of vulnerable populations. We particularly want to focus on women and children. So to achieve this goal, we want to go in 2 steps. Step 1, or goal number 1, is to capture and better understand dietary diversity patterns in order to identify vulnerabilities and nutritional gaps. And the second step is, based on this comprehensive understanding of dietary habits, provide tailored recommendations in order to promote healthier diets. Why pictures? Compared to the standard 24-hour recall module used in surveys, pictures are simple and can be taken in real time. They represent a low cost. They are less time consuming compared to answering a module, a 24-hour recall module. An image can provide precise food consumption, what is actually the people eating. And fourth but not least, we can capture information over an extended period of time. No? So we can go, for example, for a week, and we can know exactly what people are eating day by day, breakfast, lunch, and dinner. So how it works, we can think of 6 stages. The first one is a meal is prepared and served. The second one, the participant takes a picture and sends a picture to us. The third one is we can decompose the food items in the plate and main ingredients, and also think about portions. The fourth step is that the household is going to repeat the process, breakfast, lunch, and dinner for 7 days, as an example. And then we can perform an in-depth assessment of the dietary diversity patterns, habits. For example, we can answer whether the households are meeting a minimal acceptable diet. And finally, we can provide tailored recommendations based on this assessment. How will we pilot the study? We plan to embed the study as part of a planned household survey we have in Guatemala, particularly in the western highlands of Guatemala. That region, we have been working there, collaborating with USAID for several years, and that region shows a high stunting rate. So basically, 6 of every 10 children under 5 years suffer chronic malnutrition. And at the same time, it's a region where the mobile penetration rate is pretty high. 9 out of 10 households have a cell phone, and most of them are smartphones. And how do we know that? Because, as I said, we have been working in the area, and we have been actually implementing other related initiatives, also using cell phones, and actually the response rate has been over 75%. We initially want to work with 300 households, and we're going to ask them to send meal pictures over 7 days, and we're going to provide a prepaid data plan, which is less than $5, and that allows them to send multiple pictures. Now, you should see the data plan not as an incentive, but actually to overcome a mechanism to overcome potential liquidity constraints. We want that when the household sends a picture, doesn't generate any cost to them. On top of that, we're going to also make complimentary phone calls at the end of the day to ask, for example, food in between meals. In particular, we want to pay attention to snacks and sodas, which is something that is highly consumed in rural areas. And the analysis is going to be a joint effort between local nutritionists and data scientists, which we're also going to train an automatic meal detection algorithm. How is this innovative? We can think of 5 dimensions of innovation: data collection, low cost, real-time monitoring at household and individual level; data quality, capture food consumption patterns over extended period of time; data richness, pictures plus complementary information. It has also scale-up potential because we can implement this not only in rural areas but also in peri-urban and urban areas with other challenges. And we can also establish a two-way communication. No? You send me your picture, we can do an assessment of your dietary habits, and we can provide tailored recommendations. Looking forward beyond the pilot, we want to develop a self-contained data collection app where the household can submit the meal pictures and provide complementary information. We want to partnership with a cell phone provider. We're also working with TIU in Guatemala in other related activities. We want to embed a machine learning algorithm such that we can provide nutritional self-monitoring. And thank you.
Okay, I think we have a question. Stay on stage.
Hi. So after you give these people their recommendation, and given that they're the most vulnerable, how do you have any goals or ways to help them with food procurement after that to help them achieve their nutritional goals?
Yeah, well, the idea is to not only provide tailored recommendations based on the dietary assessment, but also we want to, first we want to also test whether this is making a difference or not on nutritional outcomes. And we're going to work with populations that are really in need, that they are food insecure, no? So initially this has to be in joint collaboration with international cooperation. So basically we can think also, I mean, this is from the demand side, no? But we will need to combine this from the supply side in terms, for example, if we're going to recommend something, has to be something available also in the area, no? We're not going to recommend broccoli in an area where we know it's not produced or it's not accessible, for example. No? Has to be, that's why we also have in the team local nutritionists, because they have to also give us an assessment exactly what are the options, for example, if we want to balance the diet. No? So it has to be combined a demand with a supply side of food availability in the area. Thank you.
Okay. Thank you. Okay, so we're 7 down, 3 to go. How are we doing? Going into the final stretch. So up next we have H2D3. You guys ready? Okay, ready,
Hello.
Steady, go!
Hi, so good afternoon. I'm Rhys Manners. This is Robert Hymans. So, the triple burden of malnutrition is still a global challenge that's affecting both our food and health systems. Yet despite 35% of the global population actually being affected by this, we're still largely in the blind about what's going on. What data we actually do have is largely national aggregates of annual data, but if we actually want to disaggregate this and have disaggregate this information and understand what's going on at different locations and different times, we're largely in the blind. So, as a society, if we really want to address malnutrition and we really want to understand what's going on, this is a data gap that we really need to begin to fill in. So, as Citizen H2D3, this is our response, to begin to fill in this data gap.
We all need balanced diets to lead healthy lives. Best efforts to understand this challenge have been based upon limited data. Existing data on household dietary consumption are often fragmented, static, and limited in scale. This data tells us what and how much people eat, but does not provide spatially and temporally dynamic insights. If we are not monitoring household consumption patterns consistently over space and time, how can we begin to address malnutrition? Digital tools and big data can help us. Citizen H2D3 is a scalable real-time data collection system, gathering information on household dietary diversity from volunteers. Users can sign up anonymously using their smartphone, tablet, or laptop, and their privacy is at all times protected. Through the gamified feature of random micro rewards, users will be incentivized to participate actively. Citizen volunteers will be asked on a daily basis about their household dietary consumption. Data is sent to a central database where automated analysis will be implemented to generate information. This information will provide evidence-based insights for understanding malnutrition and the role of gender, income, and education in driving these patterns. With these insights, decision makers will be able to tailor responses to the needs of specific target areas and populations. In the future, Citizen H2D3 will provide specific feedback to its users, inspiring positive dietary behavior change and empowering households to make healthier decisions on which food groups to eat. Citizen H2D3, empowering citizens to eat well and live well.
Malnutrition is one of the greatest scandals of our time. There's 800 million people are undernourished. Perhaps as many as 2 billion people eat too much. And this is not because we don't have enough food. Generally, we do have it. It's also not because we do not know what a healthy diet looks like. We do know that too. And yet, interventions often fail to address the problem of malnutrition. And one of the big reasons is that we simply do not have the data to know what people eat where, in different locations, and when throughout the year. It's a wicked problem, and we just simply need more data to do the research that we all talk about, to think about linkages between agriculture production, food consumption, and nutrition. So the users of these data will be researchers, and hopefully it will lead, and we believe it, and we know it will lead to better policy by governments, as well as better targeted interventions by NGOs. How will this become sustainable? Well, we start out with these micro-incentives and money. But we'll gamify it further. People will get feedback. It will become much like a health app that will either track your number of steps or nudge you towards better health. It may compare your diet with that of your neighbors, etc. There's also, we're already in contact with large NGOs in the nutrition and as well as in the agriculture extension business who would be paying for using this service. We have a wonderful set of partners with years of experience in nutrition, data science, and implementation of projects, including the Rwandan government, who is fully invested in getting this project going. Thank you very much.
I have a question. As this is voluntary, if you don't think there will be some bias in the data that you are collecting, I mean, those that are more aware on what they eat or they consume.
No doubt there would be some bias in the data that we would be collecting. We never let think that it's a huge step forward based on where we are now, where we basically have no data.
And also part of the system, there's also a validation. So as volunteers actually submit their data, we'll randomly select between 2 and 10 individuals to actually call them up and actually check whether what they're doing or what they've said and submitted is actually what they've, to just recall whether it's the same.
Okay, thanks a lot. Round of applause. Okay, next up we have Real Good. Now it is your turn. They were so eager the last time. Okay, ready?
Yeah.
Ready? Go!
Okay, hello everyone. We're the Real Good team. It's a new partnership between Future Pump and EME. Globally, food demand will increase by 50%, while at the same time, water scarcity will impact over 1 billion users. Sorry, hold on a second. This is not working. Yeah, I'm pushing the green button. Oh, okay, there you go, when tech fails you, right? So we will rely on climate-smart investments to really help make those smallholder farmers being more resilient. And therefore enable the potential of creating and increasing the irrigable land from 2 million to 40 million hectares will impact 185 million people. However, some countries actually do have not so much expansion potential left, and this is why we are here today. We are actually combining the solar suitability mapping with real-time live data on groundwater to really help farmers identify where there is a true potential and where there is a potential risk of wells running dry mid-season. We have developed a solar suitability tool that uses different remote sensing products, such as solar irradiation, but also groundwater depth, aquifer productivity, travel time to markets, etc. Now, one of the main challenges is that groundwater data is really difficult to find, especially at fine resolution and especially understanding their temporal variability. And that's why, at the moment, we're partnering with Future Pump.
Future Pump manufactures solar-powered irrigation pumps for smallholder farmers in the tropics. We have over 4,000 pumps with data loggers in the field globally. More than 3,000 of those are in Africa. The pumps are tried and tested. They're robust. They're farmer fixable. They come with a 5-year warranty. Most of those pumps with loggers, they measure the power that the solar panel provides, the power that's used by the pump, and the number of rotations that the pump makes. The data loggers record every minute, and we have over 153 million data points in Africa to date. But mostly this data goes unexamined. It can be used to estimate the groundwater abstraction. It can be used to estimate the power that the pumps have used. We're really excited to collaborate with Ndvi in using the data that we have to start to help answering some of those important and timely questions around groundwater abstraction and around solar suitability mapping.
And that's exactly why we're here today. We like to combine this data with the remote sensing products we already have at hand, so that we have a better understanding of what's really happening on the ground. We are proposing to take one particular watershed in Kenya to test out our idea, where we actually look at recognizing patterns on why pumps operate or not operate in a specific space of time. Where we know that, we can actually estimate a water abstraction in real time and link that to the recharge that happened during a season. This allows us to actually predict when farmers would turn into risks of not being able to produce what they need to produce to pay back their credits. So linking everything back to the solar suitability tool, it actually enables the private sector, such as Future Pump and its distributors, to target better their investments. And at the same time, it also helps farmers to de-risk, because they will be able to pay back their credits. For the national departments, actually, it is a welcome data set that will enable them to develop their regulatory frameworks and meet the SDG 6 that everybody is working for. While we're trying to target this today, we do also think about tomorrow. We have heard a lot of interesting climate service pitches as well as crop advice models. And if you combine all of that together, we are sure that we can actually develop the resilient food systems for tomorrow. Thank you.
You're all good? Okay. Real good. Thanks a lot. Okay, last but not least, in the randomized order, we have one village, one mill.
Good afternoon, everyone. I'm Sarah Hobgen. I'm from Village Infrastructure, and I'm here to accept the challenge to inspire you, even at 4:30 on a Friday afternoon. So the challenge that we're facing, I'm just going to tell you a quick story about the life of these women. So this is Rambu Inna. She lives in a rural village in Sumba in Indonesia. Her daily program, when she wakes up in the morning at about 5 o'clock, just before the sun, the first thing she thinks, like many of us, is, oh, coffee. She wakes up, she gets up, she has to put the wood on, set the fire, boil the water, and then she boils some more water for the drinking water for today. She does some more cooking, water for the cooking, and I'm going to calm down in just a moment. So she does some more water for the cooking, and then she sits down to pound the corn. So you can see her pounding the corn. It takes about an hour. While she's sitting there pounding the corn, she thinks, there's training on at the village office today. I'd really love to go, but I still have to collect the firewood. I haven't washed the dishes. I haven't gone to the water, and I've still got to go and wash the clothes in the river. I just don't have time. So all of these things that I have to do in a day mean that, so all of these things that she has to do in a day means that she can't actually take advantage of all those opportunities that she's being given. How can she become an agripreneur? How can she take better farm advice if she's stuck at home just because she has to do all of this work? So our solution to this is a suite of things, but one of them is an agro-processing mill. So we already have 7 different kinds of mills. for processing, 2 for processing rice, corn mills, corn shellers, coconut, cassava, kava, every mill that people have been using in Indonesia and across the Pacific. We really, really want to scale this up, but we need to understand who are the people who are in these off-grid communities? What kind of crops are they using? How are the households distributed? And for the first time, we can actually start to really map this. So Facebook has released the HRSE household data set. So for the first time, we actually know where every household is. Facebook collected it from remote sensing data, so it's not a privacy issue. And it's just that they're the ones that have the computing power to do it. Sorry, Google, but you guys should have been first, really. So the household data set means that we can use this big data to really work with the people who aren't generating any big data. So this is a use where we're actually going to those communities who don't have access to phone, they don't have access to internet, but what we're using is to understand their community dynamics better and to work out what solutions they really need. So the trials that we're going to run with the Inspire Challenge money is to work with Cgiar on bean threshers and maize mills in Kenya. So we're actually going to map all of the households in Kenya using all of the Cgiar's data on the crop distribution of all the different crops. Thanks to the big data platform with Guardian, that means we can access all different crop data. And we're going to work with CIMMYT on flour mills in India. So we're looking at solarizing solutions that are already there, or where there's not a solution, we're going to try and create a new one together. Our partnership, Village Infrastructure Angels, that's us. We actually already have experience in doing this. The mapping we've been doing already, we've mapped electrification models for countries for states in the Philippines, and also we're looking at some contracts with other companies in Africa. So that's a pay-for-use service, so we already have an income generating model for that. We're working with Cgiar and CIMMYT because they know what's going on the ground. So one of the things that we found on our implementation in Indonesia is that we have 500 mills already in use. For our rice mill, we have 2 models of rice mill, and one of them was really preferred by the farmers because the rice bran that it produced was much finer. And now when you're thinking about creating a mill, you don't think about the rice itself, you don't think about the rice bran, you think about the rice. But actually the rice bran is pig food, so it's really important that it's ground up more finely. So understanding how farmers are working in these environments is really important. That's the value that Cgiar and CIMMYT bring. Ilu Streets have a massive data platform, and they're already working with this kind of scale of data and make it into beautiful interactive maps. Project support systems are our... No! Project support systems are our... Thank you!
Wait a minute, we got questions. Never before has a chicken been so scary. Questions from the judges? Nope? Okay, we're good. Thanks a lot. So that's a wrap. That's the 10 Inspire challenges. Let's do a big round of applause for the 10 of them. Can I invite you all up on the stage? Oh, we've got a photo, have we? Let's do another one. Another one. Let's get up on the stage, the Inspire winners. We'll get a photo of them all. And the judges, please. So I must say, something that we do while they get organized, something we do, we actually, we run the prize. We had, in this case, 152 applications, and we have a whole process to whittle it down, different judges, to whittle it down to these 10, and then we do the awards. But we actually, for the last 3 years, we've been categorizing every single application and monitoring how the Inspire process itself is going. Look at this, isn't this wonderful? So we monitor how it goes, and one thing that's happening is the types of innovations are changing. They're moving into a space away from basic research into much more interesting applied, dynamic areas where research is much more hand in hand with also the scaling in the private sector and different types of partnerships to get the innovations out. So it's moving in the right direction, but also the quality of these presentations. We can do a kind of analysis, a quantitative analysis, but the qualitative analysis is, it's every year the bar is just getting higher and higher and higher, right? So the quality of these presentations is wonderful. So I'd like to do a big round of applause, not just for our finalists, but everyone for egging on an amazing process. Okay, wait a minute. Everyone has to pose for the camera. You weren't posing, apparently. Back on up. We need a pose. What kind of pose? Can you give it as an example?
One is thumbs up and one is normal pose.
Okay, so a few of you over here. We need a thumbs up, apparently. Okay, so move over a little bit this way. Go on, move along, move along, move along. Keep going, maybe double up. Okay, thumbs up first. Okay, what's the next pose we need? Next pose? Winners? Arms up in the air. We are the champions. No. Okay, that's enough. Enough craziness. Okay, so what happens now? The judges are going to go into a huddle. No one can influence them now, okay? They're going to go in a huddle, they're going to decide, and we're going to have, after the session today, we're going to go into the closing now. The buses are going to move to the Trident, and tonight we'll have the award-winning ceremony and then some live music. And so we'll be hearing later who the winners are. So, for our closing, coming up on stage, we're going to hand over to Ceci and Shamila. They have been the kind of behind the scenes making everything happen, watching what's going on, and they're going to close us off for the day.
All right. Hello, hello. Hello. All right. Hello, everyone. My name is Shamila Ashraf, and I work with AMZ, but you all might know me as Ceci's email ghostwriter.
My name is Ceci Burns. I also work with AMZ. We have been working with the Big Data platform to put on this convention, and I am Shamila's biggest fan.
Thank you. Thank you.
Let's hear it for Shamila.
And Ceci.
So I want to start off with let's call it a mindfulness practice. I want to take just 15 seconds and everybody just look to your left and to your right and acknowledge that every single person in this room is here because they are passionate about food security. They are passionate about the world that they live in. And let's just be thankful that we got 3 days to talk, to work, to imagine with the people around us.
And now that Ceci has everyone in tears, let's play a game. All right, so I'm going to ask you guys some questions. I want to get to know what you've been doing for the last 3 days. I've been running around with PowerPoints. And so what we're going to do is I'm going to ask some questions, and you're going to stand up if it applies to you. So stand up if in the last 3 days you talked to someone you did not know before the convention.
Hey!
Lovely. Now stay standing if you plan on connecting with some of those people after the convention. All right.
That's
all right.
what I like to hear.
All right. Sit down. Just kidding. Next up, Stand up if you are going to apply to the Inspire Challenge next year or in the upcoming years. All right, all right.
There you go. Look around at your competition. That's your competition.
And now, stand up if you were featured in one of Andy's YouTube videos. I was not. Oh, wow.
Some of you don't know that you're in his YouTube videos, I think.
Check them out. Stand up if you want to come to Lima in 2020 for our convention. Woo! 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 All right. And last but not least, stand up if you feel so excited and so invigorated to get back to your offices and work on improving global food security.
Every single one better
Everyone should be standing up. And that was your workout for the day.
So, as you can see, we've spent the last 3 days in super engaging conversations. And what this tells us is that we have, in the last 3 years of the big data platform, built a community that is enabling communication within the Cgiar, with external partners, with new and exciting friends, colleagues from around the world that you didn't know you were going to be working with right now. And that's super exciting. I think the number one example of this is the phenomenal Inspire Challenge pitches that we've seen today, the scale-ups that we saw yesterday. Just another round of applause for our Inspire Challenge applicants.
Woo-hoo!
And everybody, yesterday there were 6 hours of deafening conversation in the Innovation Bazaar, and that just tells me that everybody is excited, not just the Inspire Challenge applicants, not just the judges. Everybody's excited about these innovations and these opportunities. And then in addition to this, we're not just talking about this stuff. We're actually doing it. This week, we've seen not only the Inspire Challenge solutions on offer, but CGIAR solutions on offer, partner solutions on offer. We've taken it from the theoretical to the practical. We are applying it, and we're so excited to continue that journey to impact.
And I also want to take a moment to look forward. Over the last 3 days, we had a lot of people at this convention that are thinking about the next generation. Let's have a round of applause for our Youth and Data cohort. And another round of applause for all of our students, PhD, graduate level, agriculture students, and our young entrepreneurs that are here thinking about the next generation.
And speaking of what comes next, Lima 2020. October 19th through 23rd, 2020, we will be hosted by the Potato Institute in Lima, Peru. And right now, we're going to hear a quick message from Lima.
The SIP team is extremely excited of hosting the 2020 Big Data Convention. Data has been the building block of scientific progress over the years. The difference now is that we are generating a lot more data than before. Megabytes, terabytes of data are available from both scientific research, development projects, but also some other sources such as market studies, human studies, etc. Therefore, learning how to use this big data in the best possible way and combining the progress of computing power with algorithms and models and the big data will help institutions such as SIP or the CGIAR to make better decisions regarding which technologies to develop and where these technologies could be better disseminated to achieve impact for the Sustainable Development Goals. SIP is a nearly 50 years old organization. From the beginning, we have worked in a number of fronts, from the conservation and utilization of biodiversity to the development of better varieties of potatoes, sweet potatoes, and the utilization of different types of technologies for helping small-scale farmers making better decisions regarding their production, their productivity, their competitiveness, their market access. All of that can be supported by having a better utilization of available data. Therefore, SIP is committed for a digital transformation, all the way from field data collection, lab data collection, from breeding side, from agronomy side, from social sciences, in order to put all of that data together to help us move to the future and accelerate the delivery of better technologies, better solutions for farmers. Climate change is already here. It's affecting already small-scale farmers around the world. We have witnessed that happening in the high Andes. We have witnessed that happening in the deltas of Bangladesh or other countries. Therefore, we need to help small-scale farmers to make better decisions, and that can be supported by better data management, data processing, and the use of that data for decision support tools to help farmers access better technologies and organizations to design better projects, better policies. As a Peruvian, I'm extremely glad that you will be visiting my country. It's one of the centers of biodiversity in the world from which a number of key crops have been disseminated around the world. One of them is potatoes, and others are chili, tomatoes, beans, maize, etc. All of that biodiversity conservation and use generates also a number of data, much more than before. Now, with the genomics revolution, all the data comes from the DNA of our accessions all the way up to in situ conservation and how farmers are working in the mountains to conserve that biodiversity, to use that biodiversity. Therefore, the convention will not be only an opportunity for scientific change, but also the opportunity for you to know a country of rich biodiversity and the efforts of SIP to help farmers and the governments to better conserve and utilize the rich biodiversity of this country. The SIP team is
So I hope you're all as excited as I am. I'm a big fan of potatoes in all forms. This is a central fact about me as a person, so I'm really excited. For the first 100 people, we are putting them into a drawing, and one out of the first 100 will get their flight and lodging paid to SIP 2020 Big Data Convention. So we're very excited about that.
And I want to take a minute and thank our 2019 convention sponsors. We had a great amount of sponsors this year that made this convention possible, and I'm going to list them out, and then let's have a round of applause for them. We have ICRISAT, DAI, Google AI, I'll list them all. Oh, okay. The Cgiar research program on grain, legumes, and dryland cereals, ADB Ventures, and all of our booths and exhibitors that help make this possible. So let's hear it for them.
And just one more thank you to ICRISAT, our wonderful, gracious hosts for this week. Woo! Now I'm going to bring up another person that you may or may not have seen running around, the communications coordinator for the Big Data platform, the brilliant Marianne McDade.
Woo!
Thank you for that introduction. The real stars of the event are the youth who turned up this year. So if you guys want to come on up on stage. So we held our first Youth in Data workshop last year, and it's part of the platform's efforts to connect better with youth, because youth are the future, and if we're going to be feeding a global population of 9 billion by 2050, we need to be sure that we are engaging with youth and connecting them and getting them inspired about feeding the future and the new technologies that are involved in that. So please give them a really big hand of applause. So this year we had a couple interesting, well, we had quite a bit of community engagement. We had a record number of media coverage. Quite a few members of the press turned up. We had 2 local TV stations, 12 local and national media organizations. This button is not working. Okay, thanks. And to about 4 million audience reach. So, yeah, so this is the second year. We received over 80 applications, and these are the 20 who enrolled. They come from local journalism and engineering colleges, as well as our ICRISAT scholars. So we had a record number of tweets this year. So it was 40% tweet increase on last year, which is pretty incredible considering we had about half of the contributors. And that's basically due to these guys here. So they've done a really amazing job covering all of your sessions with some brilliant tweets about what's going on, and especially from their perspective, which is pretty cool. There was one in particular who absolutely smashed our record for tweets. Some of you who were there last year, you may know John, who during the course of the 3 days managed to tweet out, I think it was like 650 tweets in 3 days. But this year, look at that, 861. So Kancha, step forward, come on, come on. That's a pretty amazing accomplishment, so yeah. Anyway, so please, guys, if you can give them another round of applause. Sesame.
Okay, I'm going to stand here. All right, as they take some pictures, I'm going to invite the illustrious Brian King to close us out. Come on, you can do better than that.
Clap for me like you clap for potatoes. Thank you. Thank you. I really have not much more, if anything, to add. I do want to put out an open call to all of you and to all of your networks, and let you know that the Big Data Platform Steering Committee has 3 external members, one from industry, one from science and research, and one from funders, Cgiar funders. And there's rotation happening right now, and we need a new research lead, science lead, to join the Big Data Platform Steering Committee. And governance is such that that person would also have to become the chair of the steering committee and nominate, huh? Oh, sorry, oops. Thank you. Yeah, give them a hand. Please help get the word out. Nominate yourself. Nominate your colleagues. Know that there's an intellectual and a light organizational burden. We really help out the steering committee in terms of making it happen. Nominate women. Step forward if you are a woman. And please, let's make this happen. So, in closing, let's give ourselves a round of applause. Get on the bus. The award ceremony and dinner is tonight at Trident Hotel. And see you later. Have fun.